we can give our colleagues maybe 3 minutes again or 2 minutes so that they can join. But we start together. But today we are going to make sure that we finish all the practicals, because in terms of the slide, I've got few slides only. So I've got only a few slides. I've got 40 or 40 something, so it won't take long. So what we're gonna do, we are going to start with the practical that we were supposed to do yesterday, so that we can finish them today. And we start now with the new topic or topics. Then we do 2 practicals again for the day. And I think we will be done. I sent you an email to say maybe we can finish at 5. It's because we want to spend more time in practicals, so that we familiarize ourselves how to do things in R. Yeah, that's why I was asking 5, but we might even finish before 5. So it will be up to you. If you agree that we finish at 5, we can finish at 5. If you disagree, then I will stop at 4. But we will do our best so that we can finish in time. So I can see now we are 15. I think it's a good number. We can start. Because 15, yesterday we were 20 something. So we can start with this number so that we have time to finish the things that we are supposed to finish. Thank you very much for joining again. And once again, this meeting is being recorded. So even today's one, we've already started the recording, and we'll share with you the recording once they are ready. So today we are going to start with the practical. So what I'm going to do, I'm going to share my screen. So we're going to use the very same one that we were using yesterday. So practical, day 1, practical 1. So that's what we are going to use. So I'm going to share my screen with you. So what I've done, I've just, so that you are able to follow me, I've changed the appearance of my screen or my R Studio so that it's in white and it resembles what you have there. And you'll be able to follow me. So yesterday, what we did, we downloaded the data. We saw how to download the data in whichever format the data is, whether it's in Excel, whether it's in CSV, or whether the data is in Stata. So that part, we've done it. So what we want to do now, we want to, in fact, I forgot to tell you yesterday, I don't know if you were able to, when you finished the session yesterday, if you didn't save your session in R, it means that you have lost all the things that you were doing. But it's not a problem. What we can do, you can just do the same process that we've done in terms of calling the data. So you can do, because you've got already the script. So what we will need to do, you can call all the data as we've done yesterday on your own. So mine's, my data is still there. So I didn't change it. So from your side, what I will advise, you can start from here, but don't, for those who have not yet installed R, some packages, yes, you need to install these packages, but if you have already done that, you don't have to install them. So what you need to do, when you open a new session and it's empty, you need to do that process. First of all, you need to go to the session here, excuse me, you need to go to session, there is session, then you click on set working directory, then you choose your directory where that folder is, where you have practical 1. So once you do that, you skip this process. Don't use this. You can skip it. One way of skipping it, you can also do the same at your side. You put hashtag. I told you yesterday that when you put hashtag in R, it means that everything that follows after the hashtag will not be executed in R. So that's why you see, once I put, let me remove it. When I remove it, you see that it's in the color that it's required. But once I put the hashtag, you see it becomes like in green, meaning that it's not going to be executed by R. So you can do the same, so that, because this command is needed for you to set the folder, but you've already done it, so you to do it again. So you just deactivate it. Once you do that, because you've already installed these packages, you just skip this and you can just do this. So you need to call these packages into R session. So this one you need to do, because every time when you open your R, if you want to use a package, a function, or certain functions that are in certain packages, you need to do that. So you need to call them. So this one you need to do. Once you are done, then you can click on this one. You can click on how to call data one. You call data one. You also call data two was here. You also call data two. DA is data two. And you can also call this one also, you can call them. So you start from here up to here. No, up to here. These two, Socrata.file, you run that function. Then you also do vehicle point data, you run that function. In that case, you'll have all the data that we will need. So you can do that and it will be executed. You can also do this because you have the data. This data is in your folder. You can also load this. That will be okay. So that's all. So now what we want to do, we want to do some data manipulation. So that's the purpose of this practical, or the continuation of this practical. So I'll be waiting for you to do that. If you can you please load if you don't have the data, so that we can start together? Okay. Is everyone ready? Can we continue? If you are ready, you can just. If you are ready, you can say yes.
No, the
CSV
okay. Time to be called.
Or to do that, yes. Okay, no problem. Let me just wait a little bit once you are doing it. By the way, I forgot. Yesterday we saved them. We could have just loaded them as R data, because yesterday I remember we saved them. So loading them as R data was going to be very easy, but it's okay. It's part of the exercise, so you can do that. Because yesterday we saved them. If someone has already finished, can you tell me, and to check if we are all in order with the data? Okay. I don't know, where are we now? Who's ready?
We are getting ready, but
It's
a bit
taking long.
slow.
Okay, no problem. Let me give you again 1 minute and we'll see.
Please, you've stopped sharing. I'm trying to look at the data that you have.
Oh, you are
in your
okay, sorry.
environment to make sure that
Okay,
I
no
have the
problem.
same data.
Okay. No, it's because the white is giving me problem. I can't
Sorry.
see properly, so I want to put it in black. I'm coming back. Give me 1 minute. Because the white, I can't really see it. It's giving me a big problem. Okay. Okay, there I'm now sharing. Yeah, there we are. So I've got data one. So what we need is just data one. Don't mind about data 1.1. So you need data one, data two, data NUTS 3, and vehicle. So these ones. That's what you need.
Okay. I think I'm ready then. I don't know about others.
Okay. Is there anyone who's not ready? Who is not ready? So the answer, the non-answer means that we are ready. Okay. So now what we are going to do, it's part of the what we call data management. So once you have your data, and depending on the analysis that you want to do, so you will need to arrange your data like you do in Stata, or you do in MATLAB, or you do in eViews. You always arrange your data so that it corresponds to the things that you want to do. For instance, in Stata, they will tell you that if you are doing panel data, the data should be arranged maybe by time, then by cross-sections, or by cross-section or time. So it's depending on the function that you want to apply. So the same apply also here in R. So you need to manage your data. So you clean the data if you want to clean it, or you arrange the data in a way that it will allow you to do the analysis. So what we are going to do, we are going to look at the vehicle data, the one that we've highlighted, the one that we've just downloaded, the data that we downloaded from a portal in the US. So we are going to look at that data. The first thing, once you download the data, you need to know what is in the data. So you can use the names so that you know the names of the variable. That's what we said yesterday, that if the data is a data frame, it means that the data is given in a format of a table or a matrix, where you have the rows and the columns. Rows, we call them here observations, and columns, we call them variables. So now you can look at the names of the variables. Like in this case, you see what I'm highlighting here. You can see it where my cursor is. So you can highlight this to say names, it's a function. Names, you put bracket vehicle, so the name of the file or the name of the object. So which means that it's going to give me the names of each column that we have in this data set called vehicle September 16. But the challenge is, let me click on it. I will tell you why, what will happen. I will have an error once I click on it. And I will explain to you an error. You see, it says object. You look at what, once I click on it, look at what it says in the console. It says object vehicle point September 6 not found. So it's not there. You can even go confirm that by going to the top right panel. You can see that it's only vehicle point data. So we don't have here this one. So it means that I made an error. I should first create this object also. So how do we create this object? I go up, look at, you can look in the, yeah. You can look in here, on top here. You see class, vehicle, data, creation date. But below it, you see where I'm highlighting. You see vehicle, September 16. What does that mean? Let me first give the names. Sorry for that, because we were doing this yesterday. Let me first give the name, check the names of this data vehicle instead of vehicle September 16. So I can type this in the, I'm typing something in the console, name, vehicle, vehicle data. Give me the type also in the console because we don't have it on the script. So you can type it on the console or you can type it in the script, then you run. So if I want to go back to that function again, I will not, because you will be doing without many challenges. So let me type, let me enter. You see now it gives me the names of all the columns that we have, which we call variables. So the first one is creation date. The second one is status. Everything is there. And you can see, for instance, in terms of, creation date. Let me look at creation date. What does it mean? So if we want to look at variables or figures that are in one variable is a column. So if I say variable, it's a column. So because we've got different columns, like in this data set, we've got 26 columns, which are 26 variables. So if I want to see which, what is the content in that variable, let's say variable 1, which is creation date in this case. So what I will do, I will just write here, vehicle. We did this yesterday. I put vehicle, then you put $sign. Then you put, you see when you put $sign already, it gives me the list. So it gives you the list to say you can choose from this list already. It knows already that you want to look at things that are in variables, individual variables. So I want to see what is in creation date. So I choose creation date, then I press enter. So you see, it gives me what is contained in the creation date. So it's the date. So like here we have 2011, which was in January, the 1st of January. So you see, so there are different dates. When you go down here, you can see it goes up to 2011. So it's date, it's by month. So, and you have also 2015, all those things. So that's how you check what is contained in your data, apart from the views. We can also do views, but views applies only to DataFrame. Like this one is also a DataFrame, we can do views. But remember, with views, sometimes if you have a lot of data like this one, we have 261,000. So it's a lot. So sometimes it's a bit challenging. So the first operation that we want to do, we want to select, if for instance, you want to select just 1 month, because here we do have the dates. So you want to select only 1 month in a particular year. Let's say you want to select September and 2016, because they were also part of, these dates are part of the that variable that we've seen. So how do you select? So that's the first operation that we're gonna do. How do you select things in your data? Because if you are interested just in that, how can you select? The first one is this, we see this, what I'm highlighting here. This is a very powerful way of selecting. So you are using what we call pipes. You see these things, the one that I'm selecting here, you see the sign of percentage, then there is greater and percentage. We call them pipes. So these pipes, they come from this package that we call, let me go back. They come from this package. That's why we needed this package, tidyverse. That's where they come from. So it's a very powerful package. It allows you to do manipulations of data. So they come from there. So what it's doing here, the pipes will allow you to select the data. Let me explain, let me come back. So I'm back here now. So we are saying we want to select, you already know what is, when we put this sign of assigning things, it means that we are creating a new object. And this new object is called vehicle.September 16. If you make a mistake, you say vehicle.data, it means that it's the new one that you are going to create, it's going to override the one that was already there. So instead of you losing the data, it's better you create a new object. So this is the new object. So we are telling R to say that anything that comes on the right-hand side, whatever you do there, the outcome, you are going to assign that outcome to the new object that we've created. So that's what we do. So I'm repeating what I said yesterday. So what we do now, you put the name of the file or the data or the object that you are working on. So this is the name. Now I say pipe. These are pipe. So I'm asking R to filter. So R will filter by year. So because in creation, let me go back. Sorry for that. Let me go back to this function that we did. So this way of putting things, R will know that there is year, there is month, and there is date. So when we say year, we are saying choose the year in the creation variable. This is the creation date variable, and the year should be equal to 2016. So what R will do will filter only the information which correspond to the year 2016. So the rest, it will discard it. So that's the first thing. Because we are doing double operation, or yeah, in this case, it's double operation. First of all, we choose the year. We are done. But we also do the pipe. This is the second sign, the pipe. And the second sign, here we say filter. So we ask R again to filter by month. You see, the first one was the year, the second one is by month. Then we say all still on create, but we are choosing 9, which is September. So what R will do this operation twice. It will first filter the dates according to the year that you've allocated, then by month. Then it will give you a data that is corresponding to September for 2016. That's why we said here, vehicle September 2016. So you can click there and you will see it will execute this. Then you can highlight. I told you that you can highlight, or you can put, because we want us to execute one line. So you can highlight that line, then you click on run. Or you can put your cursor at the end of the command. Like in this case, I'm here, the end of the command. So I will click run. When I click run, then it will execute. Let me click run. I click run. So it's running. And you see, very quick. That's the advantage of that package. If you have to do it with other things, it can take you long. Remember those who are working with Excel, if it was in Excel, you have to click and select, or you put macro, maybe it will work. But here you see just a click of button, everything is done. I told you also yesterday, if you want to understand what is filter, you see there is question mark, then filter. You can ask what is filter, you can ask what is year, then it will give you that information. We are not going to do that. So what we need now, we've created a new object. You can even see on the panel on the top right, you can see down here, you see vehicle point September 16. It is now there. And you can see it has got only 2,637 observations. Instead of, so it's 10%, almost not even 10%, it's less than 10%, because 20% is 26,000. So it's 1% in terms of when we compare to this one. So we've created a new object. So another way of looking at it, as I told you, you can click add. Add, it means that it will give you, it's a function. It's a basic function which comes with R. This one does not need a package. It is already there, add. So it will give you the few observations, maybe up to 15 of that data set or of that object. So let's click on it. Let's say run. I click on run. You see it gives me, it's because of the way I've put my table, because we've got 26 variables, that's why it's a little bit complicated to see. But you can see that when we look at creation date, everything here from 1 up to 6, it's 2016, it's September, it's, you see, September 2016. So you won't find anything apart from 2016 September, because that's what we told R to go and select for us. So it gives us this. So the second thing also to check, to know whether you've done a good job, you can first, because this data that we've just created, we created it from vehicle point data. So what do we do now? We compare the two. We compare the old one, the parent that I call it, the main data, and the new one that we've created. We can compare their dimensions. You remember, this is like a matrix. So row, number of rows and columns. So dimension gives you that information in terms of number of rows and the number of columns. You click on so you run dimension for the parent data. So it says it's 261,026 variables. So you also click on dimension for the child now, for the new variable that we've created, new data that we've created. You also run, it says it's 2,637. So you see that this one is smaller in terms of number of rows. It's because we've only chosen 2016 and only for September. So this is the first operation. So you can select some information from your data using this way of doing things. So by using tidy, this, filter, and all those kind of things. So that's one. There are many ways of doing it. This is just one. So now that we have September or vehicle point September, now we can click here to give us the name. You will see that it will not give us an error, because the data sets we've already created, it's already in the session. So we just click run. So you see now this time there's no error. It's because we've created it. So it gives you the names of the variables, the columns. So it starts from creation date, status, completion date, and so forth and so on. You see? So we've created the first one. We want to create the second one so that you can see again how to do it. We want to create another data from the big one. So this one we call it vehicle point final. So what do we do? So we tell R to say whatever we are going to do on the right hand side, that outcome, assign it to a new object, and that object is called vehicle point final. So we do the same, the name of the data, but in this case, we want to select from the one that we've created, 2016. So we select, but we select, you see now we put select here instead of filter. So the difference is that in select, we are selecting the columns. remember when we were doing the filter, we were filtering according to normally it's the rows. When we say filter, you are filtering according to the rows because creation, the variable creation gave us the rows, and the rows were in years and months and days. So in this case, we want to select some columns. We are not selecting rows anymore. So we are saying select. Instead of putting filter, we say select. So select applies only when you are selecting columns. So we use the pipes like we tell R select, then you give the names of the columns that you want to select. So we want to select 3 columns. We want to select community area, we want to select latitude, and we want to select longitude. First of all, we need to check if they are there. So that's why we needed that names. Let me repeat again this function of the names. You will see when we say names, you can see that column 3, the name of the column is completion date. And let's see, where is community area? Community area is there on on column number 18. So it's there. When we say community, it's there. And the latitude and longitude, they are there. Latitude on 20 and longitude on 21. So they are there. These names are there. But what complicates the matter is that when we select this, we are giving them, you see the names are a little bit funny because they are long, and so sometimes they can complicate. So we select, then we tell R, you can rename those variables or those columns, but giving them these new names that we are giving. That's why we are saying com is equal to community area. So it selects community area, then it renames it in the new object. So latitude, it selects latitude, then it renames it to lat. Longitude, the same. It renames and it selects, then it renames it. So let's see. I can run this function. When you run this function, it's okay. It's already there. We can see that the function, it's just 1 minute. And I've also clicked on add. I want to see now these variables, the first few. You see, because we selected 3, you see now we've got only 3 columns. It's no more 26. We've selected only 3. So we have these 3. So the first column is called com, which is community area, lat, it's latitude, and long, it's longitude. So it gives you, so already you can see that you've done a good job. You can do the dimension also, check the dimension. Can see the dimension. This vehicle final, it's still, in terms of the number of rows, still the same. We didn't change the rows, we just selected the columns. So that's why it will be the same as vehicle point September 16. But what changes will be the 16. So this is point 16, but for the final, where is the final? Yeah, the final is there. The final is there. You see the number of columns, the number of rows didn't change. They are the same. What changes is the number of columns or variables. Here we have in vehicle point September, we have 26, but in vehicle final, we have only 3. So this is powerful. You will familiarize yourself when you go and work on your own how to do the filtering. It's very powerful. I know you are used to Stata. Stata also does that. But in R, you also have that possibility. That one. So here, in this case, we've used the functions from tidyverse. You see, in terms of selecting things that you want from your data. But there is also another way, as I told you, of selecting without going that route of tidyverse. You can select using other variables. So we are going to look at the data which we called data nat 3. Let's first I'm going to click on the name. I think you have that data because it should be on your we did it yesterday, and even this morning I told you to download it. So let's see this. So we say names, data net 3. You see, when your data is already in the session, when you start typing it, already R gives you the int to say it's there. So it just proposes to you, to suggest to you to say, you can select it. Then you select, then it's there. So if it's not there, you will see that when you are typing, it can't tell you anything. So that's the advantage also in R. It gives you those ints. So let's say, there it is. So we've got, how many variables? We've got 17, 18. So we've got 18 variables and their names are there. So now we want to select, let's see what is in here. Let's say I want to see what is in variable here so that I can see the variation. So as I told you, if you want to see what is in one variables, you just put the name of the data, you put the sign, $sign. You can see once I put the $sign, it suggests, it gives me what I want to choose and the option. So I want to go to here. And when I click here, you can see that 1977, and it's not in order, but you can check, see that there are many years here. And so if I'm interested only in 2003, so the data just pertaining to 2003, because this is panel data, by the way. And if you want to do cross-section, you are not going to deal with these. So you just select one here so that you can do cross-section, for instance. So if I'm interested in just 2003, what I do, as I told you, I create a new object, which is data 2003. So I'm telling R, as I told you, that everything that is on the right-hand side, do the thing that I'm asking you to do. The outcome, you must put it, assign the outcome into this, what I'm creating now. So the function is subset. You see there, we talked about select, we talked about filter. Filter is the corresponding or the equivalent of subset, because filter is looking at the rows. So subset is also looking at the rows. So you can do that. You can understand that logic. So we are saying subset. You put, this is the syntax. You put the name of the object that you want R to go and fetch and subset for you. So the name is data_nat3. Then you put comma. You put the name of the variable that you are asking R to go and select for you. If it's a multiple variable, you need to do the combination. But in this case, we are just interested in the year so that we can choose 2003. So you say, go to this variable called year and select for me where it's a logical condition. Select everywhere where there is 2003. So that's why you say year is equal. When it say equal, you need to put two signs of equal. So it's a logical condition operation that you need to work with. So select where it's 2003. So R will go and select 2003 for you. So I'm going to click here. When I click, you see it's quick. It's already there. And you can check the names of these. You can check the size as we did in terms of dimension, in terms of whatever. You can do the same. So it's okay. We're going to skip that because we've done that in the first one. So if you, another way of looking at whether you've done also the proper job, you can do also differently. Like in the first case, we've showed you the dimension, the head, and all those kind of stuff that we can check. But there is also another possibility. We call it unique. Unique is a function in R. It is a basic function like subsets. It comes with R. So unique, you are telling R to say, give me only the things from this object that are unique, that are not repeated. So like in this case, we've said this is the main function, the main data, which is data max3. So we can click on it to see the unique value of this function. Let me click on it. Let me tell you what it will tell me. You see, it gives me only the unique. It means that if we have 1977, there are many 1977, but I'm telling R to just give me unique, only one. So if they are repeated, don't count the rest. So it's a way of seeing the range. So this is another way of seeing the range. So you can see now that here it's possible to see the range of this data, of this panel, because it starts from 1977 to 2015, because I've told R to just give me the unique values. If I didn't put unique and I just say data net 3 and this $sign here, it was going to give me all the data, all the observations for that variable, like we did earlier on. So this way is just to see the range. So the same applies with the new one that we've created. I can click here. You'll see it will give me the range. You see it's just one. Because why is it one? It's because here we just selected 1 year. So it's only 1 year. Although they are repeated, but it's 1 year. So it will just select one and ignores the rest because they are the same as the one that has been selected. So it's another way of looking at whether you've done a proper job. So if you clicked by mistake, you click here and you find that there is 2003, there is 2001, there is 1997, it means that this subset that you've done, there was a mistake. So that's another way of checking on it. So can I take, maybe if there is a question, let me stop here before we continue. I forgot to check every time that people have to ask questions. If there is no question, I can continue. Yes.
Yeah, I think
yes,
for me,
Prof?
it's just a small. Yeah, for me, it's just a small question. You see where you put double equal sign. What will happen if you only put one equal sign? Or is that the language
if
that
you put?
Yeah,
it will not. It will give you something else because this is a logical.
Okay.
So when you say equal, it should be double sign. And they will also see an exercise where you can put greater than or less than, or you can combine both. We'll also see those examples.
Okay.
It's conditional logic that we need to put there. Yeah.
It's the same thing with theta. Theta, you do the same with theta.
Okay. Thanks, Prof. Sharp. So let me continue with my screen. So now we've seen how to select data in a different way, but only for this one that we've seen here is just for rows or the number of rows. Yeah, I've done that. Like this first one, it's just the same. I think I'm repeating. I don't know what happened here. Yeah, this one is the same as this. So we don't need this anymore. So let me do this. Yeah, here I wanted to say it's override. Yeah, that's what I wanted to say. So if we try to rerun this exercise again, it will override the first one that was there. So you can run this function. It's the same as this, but it will override the first one. But in this case, there is nothing to fear about because it won't change anything. So we are not going to run it. So there is another way of subsetting. We've seen the first one, but you can also subset by columns. Remember with the one that we've seen filter and select. So you can also select by columns or subset by columns, but not using the selects as we've done with tidyverse. So like in this case, for 2003, let me separate it so that we can see properly. For 2003, let us check the names of variables that are in data 2003. When you check the names, you see you do have 18 variables and their names are there. Let's say I want to select only 3 or 4. So I want to select NAT ID, I want to select Alpine, I want to select category, for instance, and I want to select this per capita GDP, and I want to select population density. Where is it? It's somewhere there. Yeah, I can't see population density. I don't know. Yeah, here it is, population density. So we saw in select with tidyverse that you need to put the pipes, then you tell R select, you put the names of the columns. That's what we saw. But in this case, you don't have to do that if you don't want to use that. You just put like we've done. So we are saying data 3. Remember, caution now here, whatever I'm going to do, it's going to be assigned to this, but there is already data 3, data 2003 there. So it's going to override. So we'll not have this anymore. We'll have a new one, which will be this one, which will be different from this one. So I'm doing it on purpose so that to show you the override. So I'm telling R, create a new data set, which is data 2003, by doing whatever I'm telling you to do on the right-hand side. And you put the name of the data that you want R to go and do the thing that you want them to do or it to do. Then you put this bracket here. You put comma. Remember, I told you yesterday about it here, because this is a matrix. DataFrame is a matrix. So it's always represented in columns, a number of rows and columns. So by putting the comma there, you are telling R that I don't care about the number of rows. So take them as they are, all of them. So don't go and choose any, just take them as they are. So that's what we put there. There's nothing there. And we put comma, then you put C. C in R means, it means columns. That's what it means. So I'm telling R to create new columns, but those columns will be selected from this data. Then you put the names of those columns that you need to select. And the names should be put as they appear here in that data set. If you make a mistake, R is very sensitive, it will give you an error. So let's just for the purpose of understanding, let's say per capita GDP, let's put P in capital, and let's see what will happen. But before I run that, I want to also emphasize on the quotation marks. I told you yesterday that R doesn't care in terms of the quotation mark. It could be double quotation mark or single quotation mark. So yesterday we were using double. So here in this example, I'm using single. So there's no problem. So once you need to close you need to close them by this parenthesis. So let's click on it and see what will happen. Let me run. I run. You see, it gives me an error on the console. It says error in DataFrame. So there is an error. And at the end, it says undefined columns selected. It's because of this. The challenge now with R is that I don't know for those who are using Stata how it happens. It doesn't tell you which column did you make a mistake. It just say undefined columns. And you see it put there in plural, whereas it was just one. So you don't know which one. So that's the challenge also of R. It doesn't tell you that there is one column and it's this one. It doesn't give you that. So let's correct
tell
it.
You that variable is not found.
Okay.
In that one, yeah.
Okay. No, thanks a lot. So let's correct this. Let's put it as it was. Now let's run it. I've corrected it. and I run it, you see now it's okay. It has selected for me. But by selecting, it has overridden the data to 2003 that was there. This is a new thing. How do you check that? You check that by, you can say the names again. You go by the names, data 2003. You see that there we had 18 variables, but here we have only 5. So it means that it has changed. So that's how you do it. So I've shown you how to select through rows and through columns, and using 2 examples in different ways. So you can also, let's say you have missing observations. We did it yesterday. You can tell R to say, remove all the missing observations. So it will delete the lines where there are missing observation. And the function is NA omit. Then you put the name of the function or the data sets. So it will do that. So it has removed if they were. So that's how you do it. So, okay. So now we want to also see another way of selecting. You see here, I've selected these things here. I've selected them by giving the names that I have. To say, go and select the columns. Even here, I've selected by giving the names or the value of the rows. So you can do the same also differently. So this is the third way of doing it that I'm going to show you. For instance, let's look at data 1, a data nat 3 again. Names, data nat 3. You see data nat 3 has got a variable called year. And in that variable called year, the year starts from 1977 up to 2015, as we saw. So now I want to select only 2003, the year 2003, as I have done here. But I'm going to read it differently. So I'm going to create a new variable. I don't want to override 2003. I'm going to create a new variable called final data. Then I put the name of the data set that I want to go and work with. Not subset, but this way I'm putting the name. Then I put the brackets. These brackets, then I put the name of the variables. But this name, I'm not going to put it just here. I have to put first the data set again, the $sign, the year, then I say equals to 2003, then I put comma. What does that mean? Remember what I told you, that it's a matrix. It's rows, rows and columns. So like here, it now appears very clear. It says that I'm selecting the rows, and the row should be, and what rows? It's row 2000, where the year is equal to 2003. In terms of the column, don't worry about the column. So you can take all of them. So this one normally should be equal to this one. That's how it should be. So it's another way of selecting. Let me click on it. I click on it. So it will give you the same. You can go and check the names of final data. You will see that it only selects the year, but the number of variables are the same. Let's look at unique. As we said, unique final data. Let's see in terms of the year. So I want it to give me the unique year. You see, the unique year is 2003, as we did in that case. So it has done the same job like this one, and it has done the same job like the filter. That's how it is. So here again, I want you to pay attention. There is also another way of selecting. I say final data, which. So I'm telling which one. So it's another way of selecting which, data nut, yeah, the same. So it's just complicating matters, but I prefer this one than this one, but it will do the same job. It will do the same job. So let me skip this because it's almost the same, you know the logic. And yeah, so now I want to a little bit talk about this. This is very important because we are using now combination of selecting. So I want to select the same logic using the brackets so that I select, but I want to use combination. So let's assume that, let's say you have, let's go back to names of data nuts.
Uppercase.
Variables, you want to select, first of all, where the year is equal to 2003, but you want also to select the state. Look at the state, there is state here. So let's see what is in states. The names of states. As I told you, you can check the name or the content of a variable by $sign. You put state. So you see in state, we've got different AT, whatever. So it's a long list. Even these ones, they are included. It's just that it's very short. But if you know which state that you want to select, like in this case, we want to select DE. So I think it should be Denmark or something like that. So I'm saying select only Denmark and select France. So what I combine now. So I'm telling R, go and select only the rows that apply to 2003. And this is and, not and or. There is or and and. So 2003 and the state, which means that the rows where the state is equal to DE, this sign, you see it or. It means that, you know, the intersection and the union. Or France, which is state could be France, or state could be Italy. So what does that mean?
Sorry, just a second.
Yes, Prof.
When I said names, data nut, $sign state, gave me like null. Is there something, is there probably a mistake that I have made?
Let me stop and can you share your screen? Let me see it.
Yeah. Okay. Let me okay. Let me share. I want to see. Yeah. This is, can you see?
Yeah, we can see. Where can you select? Okay.
Yeah, it gave me this null.
What does it? Then there is a problem because the state should be there. Let me see. Okay, can you put it down? Let me see.
Okay, can I write it again?
Yeah, I see the mistake. It's because you say names. Names, yeah, I see. Don't write it. Names, it only gives you the names of the variables in the data set. So the mistake that you've made is by putting the $sign. When you say $sign, it's one variables. So name does not apply to a single variable. It's the all data set. So when you say names, it should be names data net 3 only. It will give you the names of the states of the variables.
Okay. So
what is it that you wanted to do?
Yeah, I wanted to get exactly what you got. So
no, if you want to get what I have, just remove names.
Okay.
Remove names and remove the brackets.
Okay.
And remove the brackets and click. You can do it so that we can see.
Okay. So I must not type names. I must.
Don't type names. Names is a function that will give you the names of the variables in the data set.
Okay.
But if you want to see what is contained in a variable in a data set, you don't put names. You just put the name of the data set, $, and the name of the variable. Then it will give you. Do the same.
Okay.
So you see.
This one, let me do it.
Yes.
Watching.
Yeah.
Okay. And then
$.
Sorry.
$.
Okay. And then state.
State.
Yeah.
Click on it. There it is.
Okay. Very good. That's what I wanted. Thank you.
Okay. Sharp.
So
Pleasure.
let me now stop. Trying to stop sharing.
Yes. Okay.
Yes.
Thank you very much.
I'm becoming sharp.
I can see. So now what we are doing now, we are creating a new variable, a new data set, which we call def, which is Denmark, France, Italy. That's what it is. So I put that abbreviation there. But we are only selecting the rows that correspond with 2003, but will contain Denmark, France, and Italy. So you see here, for instance, I put the first one in brackets, then I put the second one and apply to everything that is here, because they are double brackets, as you can see. This double bracket, it means that it applies to where there is, let me put it big so that you can see. So double bracket, this bracket is the same as this. So if this end is for all these three that are here, but for the three, I'm saying it can choose Denmark or France or Italy. So or we use this, or means union. So it's everything that pertains to D3. But and it's just one. You see? So you can do the same. And remember, we are putting comma here. This comma means that we don't care about the columns. We are just selecting the rows because it's a matrix again. So it's a combination. Let's see. And click on it. It has done the job. So you can go and check whether it's true. It will still give you the same. You see? So I'm not going to go here again because it's the same. So this is just to show you how to select. So you can play around with this. And I know it will be very difficult for now, but as you get along, you'll manage to see it. So the last thing that we want to do in terms of data management is how to check the missing variables or missing observations. Missing observations normally in R are represented by NA. So let's create an object called X, which has got missing variable. That's why we put NA there. And to show you, we click there. So X is there. Let me see, if you want to see, because this is just a vector, you can see it even on the console. You just click S because it's there already. So it gives you what is contained in X, very short and very sharp. But how do you know that there is missing observation? So there is this function called isNA. So you are asking R, is NA? Let's ask it. Is NA? Or we can run it. Let me run it from the script. You can run it from here. When you run it, so R gives you this funny thing of logical thing to say false, false, false. So it's the way R understand it is like it's a condition that you've put it, then R returns also the values in these conditions. It says the first element is false. False means that it's not a missing variable. It's not a missing observation. There is an observation there. That's what false means. Because your question was, is NA? That was the question. So you can see 1, 2, 3, 4, 5, 6. The fifth element, that's where it responds to say true, meaning that it is a missing variable, a missing observation. So that's what it means. But imagine if you are working with thousands and thousands of data and it should give you this false, and you won't know it because you'll miss this thing. You won't know. So that's the problem also. So you won't know. So what you normally do, because of that, you can tell R to count the missing observation, so that at least you have an idea of how many are there, so that you take a decision. So what you do, it's like double. This is a double function. So the first function is NA, which is NA in X. Then you say sum. Then we are asking R to sum the outcome of this function. So let's click on it. When I click, it says it's 1. So it says there is only one missing observation. At least here, you have at least an idea. If you had a lot of data, and let's say you have 2,000, then it gives you to say there is only one missing value, observation. Then at least you can take a decision to say, I can ignore it, or I can, So that's how you do that. Mm-hmm. So let's check in data 1. You remember data 1? The one that we downloaded for mini data. So we are checking how many missing values are there. Values. So we click there. You see what I was telling you. False, false. How do you know that they're true? You can't even see, because false, 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 false. Maybe true is there. You can't see it because there are many false. So you tell R, sum it for me, and R will sum it for you. It says 0. There are no missing observation. So that's how you also check. You also check in R. So
sorry, when it says false, false, it means that
it means that the value is there. It's not missing.
Okay.
Because the question is NA, then it says false. It means that it's not NA. Yeah.
Okay. Thank you.
Yeah. So that's how you can also do that. We can also count the number 5. Let's say the X that we've created. Remember the X object. Let me call it. We'll take a break at 11 for 10 minutes. So let's say X. You see X is there, and the values, this is a vector. The values are 23, 5, 3, 5, 7, NA, 7. So you can also count how many times 5 appears. One way of doing it is, and you say sum where X is. Let me just show it to you in this way. Sum X is equal to 1. Why does it? Let me see. No, excuse me. I'm missing something here. X is equal to 5. Yeah. Let me jump this because I can't understand what it says here now. I forgot what I was doing here. I will come back to it when I work it or later. Excuse me for that. So let us see the plotting before we go to spatial data. Let us go to plotting. You can plot data like you plot also data in any software. And you remember the data 1 that we've downloaded. Let me see data 1. Names, data 1. Data 1. So we've got the variables. You can also view it. Let's see view. Data 1. I view data 1. You can see data 1 is there. We've got this table of data 1. So it's the first that we've loaded. So you can plot it in R. So that's what we are trying to see now. So there are 2 ways of plotting. You can plot in R so that any plot that you create in R will appear in this bottom panel on the right-hand side. It will appear here, where I'm putting the cursor here. That's where it would appear. So let's put an example. Don't care about these windows. I'll come back to it. Let's plot data. This is a basic plotting. So the function is plot. Then we want to plot, we want to see the scatter plot of between operating expenditure and operating revenue. That's what they mean, OpEx and OpRev in data one. So what you do just plots. You take the name, the data one, the variable, the sign of the $sign. So it will plot you these two variables from this data set. So let's click on it. And while I'm clicking on it, observe what will happen on this panel on the left, on the right-hand side, on your right-hand side of the R Studio. I click on run. When I click on run, it takes time, but you see there is a plot that appears there. If you click also, you must have also a plot. And it's a very nice plot. It shows you a very, very positive relationship between the two. And it's you can see it. So this is how you plot. That's why we were talking about the panel, the importance of the panel. So you can see the plot here. But there is also another way. If you don't want to see the plot appearing here, can you see where my cursor is?
Yes.
I'm moving it. Yes.
Yes.
So there is this broom. Can you see this broom? I put my cursor on this small broom and it says clear all plots. So I can clear this plot. I click on clear. It asks me a question. Do you really want to? I say yes, clear it. It clears. It's a broom. I broom it. So if I want I don't want my plot to appear in this screen, but to appear on a separate screen, which is a new window. There is a way of doing it. I'm just trying. I don't know if you will be able to see it. Let me try. If you are not able, but you can do it on your own. So you first click Windows. So Windows is a command. It means that R will create a separate window, and it understands that in that window you want to put a plot there. So let me click on Window and let me run it. When I run it, can you see the new window that has appeared? Can you see it? You can't. Huh?
I can't see, but I have seen what they've done.
Yeah, from your side you should see. Yeah,
okay,
do it on your side.
Let me try.
I have seen mine.
Yes, okay. Then after you've done that, go now to plot this one, click on run it. So that the figure that we've seen recently will appear on the new plot windows that we've created. So I'm clicking on mine. Click on yours, you will see now the new graph that you've created. It's on a separate window. Can you see that? Yeah, thank you very much. So that's how you.
Yes, I can see.
Yeah, I like this one because this one it's big. At least you can see on a separate, and you can even create. The advantage of this is that if there are many plots that you want to create along the process, you can create these windows as many as you want. So you will have different, instead of, because if I want to create a second plot, if I was in R plot, it was going to eliminate that one and put a new one. So that's why I like this. Yeah. So we've created the plots. Very simple, like in starter. So that was the simple plot that we've created. So let me go back now to creating plot without that window. So you can eliminate that window. You can also, you can delete it.
Delete it, yeah.
Yeah,
Should we just close it?
Yeah, because if you don't close it, whatever you'll be creating, it will be going there.
Okay.
Let's just delete it first. Then let's use the one that we've used previously. So let me click on it. I'm running this function. So when I run this function, I click there. So what has happened? I don't know what has happened. Windows should happen. Yeah, there is a problem. I think I made a mistake also. Okay.
Mine is okay.
Mine is okay.
Now it's okay. Yeah, I didn't delete mine also. That's why it was going there. So there it is. So this is a simple, but let's say you can see this graph as it is. There is no title. You want to add a title on it. After you've created it, you can still modify it. So that's what the second plot is. So the second, this one, the second command. You can see the difference between the first and the second is that in the second, instead of stopping here on op rev, I put comma, I say men, so it's a title. Men, I say graph. Then I also rename the x axis and the y. So x lab, it means that x, I'm labeling the x axis. So that's what x lab means. So I'm labeling it to say it's operating expenditure, and y labeling, so the y is here, operating revenue. I rename it operating revenue. So let me click and you'll see the difference. Let me run it. When I run it, you see what happens. It's a new graph. Now there is the name of the graph, which is called graph, just graph. And on X, instead of putting that funny thing, now there is a new name, a nice name, which says operating expenditure. On the Y, you can see operating revenue. So you can do that in plots. And there are ways of doing this in plot. This is just simple plotting. You can do that. So I think we are also done. Let's say, no, we are not done. Let's say you want to, we've done this plot, you want to add pitch and the low end. You see that P, say H is the shape of the point. You want these points that are represented, you want it to be in a certain shape, whether it is big or small, so that you can see. And LD, YD, it's, for instance, the line or point. So if you want to modify it, you can also do it. So what we've done here, we said color, even the color, you can also add colors. Because here, we didn't have colors. Excuse me. Seems that, yeah. So if you want to put colors, you can say color according to the ID. ID is the name of the municipality. So it will give you different colors because they are different municipalities. So I can run this, observe what will happen. You see, now it has increased the size of the point, but not only increased the size of the point, it has given me different colors because they are different municipalities. Because I've colored them according to the municipalities. So that's why you see those different, but it's not, it's very ugly. It's not yet good because you can see we've got similar colors. Does it mean that it's the same municipality? No, because municipalities are individual here. They are unique. So you shouldn't have different colors. You shouldn't have colors that are repetitive. So that's the problem of plotting with simple. We call this simple plotting. So there is another package which is very important, which can assist you to do the plotting. And that package, it's ggplot2. So that's why it is here. So what I'm asking you, because some of you don't have it, can you see where I've highlighted in the script?
Yeah.
Yes.
Yeah, so what I'm asking you, remove that hashtag. You can remove that hashtag. And you see when you remove it, it's now in white. Remove the hashtag, it will be like mine. I've removed it. You can see mine now, the way it looks.
Let me see. I remove mine and doesn't show, it didn't change the
No.
color.
Okay, maybe it depends on the font that we are using, but the way it appears, you will be able to run it. So the reason why we've removed the hashtag is to say you need to run so that you need to install this package called ggplot2. So you can highlight it and run it from your side. So that's what I'm asking you to do. You need to do that.
It has changed.
It wants to restart my Arrow Studio.
When it says restart, click no, but it will install it. You click no, you don't click restart. You click no, it will install it.
Okay.
Yeah.
Mine is also saying one or more of the package to be updated are currently loaded, restarting.
It means that you have it. Does it say restart? Don't restart because you lose the data.
Okay. It says restarting R prior to install is highly recommended. Do you want to restart? Okay, I must click no.
No. If you click yes, it will preserve your data. I've just done it. Yes preserves everything.
Did it do that? Okay, in that case, yes. But mine, I refuse it because it restarts. And can everyone do that? And we come back to it. So once it is installed, now you can click on library, because library, you are calling it now in the session.
Okay.
Remember what you said when how do you call the packet? Okay,
so you said that I must click yes. Do you want to restart R prior to install?
I normally click no, but Prof. Ngepa said he clicked on yes, it has preserved his data. That's okay. But even
Prof.
if you click
I'm not setting you up. I did it.
Prof. Prof. Ngepa, if something happened to me, okay, I'm going to click yes, ne? Yes, per your recommendation. Backing up.
So we are waiting. Yeah.
Let me see. It's backing up our session. I don't know why it's taking longer. Eh?
Yeah, it took.
Yeah.
Okay. So then I go to library. Oh no. Okay, resuming.
Once it is installed, you need to go to library.
Okay. Let me see. It is resuming our sessions.
Okay. Once we finish this,
and then it says enable automated crash reporting.
Oh, there is a problem there.
May we upload crash reports to R Studio automatically? Crash reports don't include personal information. So should I click yes?
It means that your computer crashed.
The whole computer?
No, your program, sorry. The program that you are, You can click no because it's gonna take long. Just click no, it's okay. Even if it crashed, there's no problem. We'll download the data again. So the rest, while Prof. Eta is downloading, the rest, you can click on library. Library, so that you click on this one, library GDP plot2, so that you can call it now in the session. Prof. Eta will follow us while he's doing the downloading. So once you click there, this is a nice package in terms of plotting. So we can plot the very same information that we were using, let's say, plots. Let's say we want to plot the scatter plot, the relationship between operating expenditure and operating revenue. So what you do, ignore these windows. Don't touch it, ignore it. So I'm here. I am here. So here you can see that I'm going to assign the plot a name, which means that I don't want it to appear first. I want it to be whatever, as I told you, whatever R is going to do on the right-hand side, it will be assigned to this new object. So I assign this new object, I say GG data1. Now I put the function. The function is ggplots. Remember the package is ggplot2, but here ggplot. So don't confuse. This is the function which is part of ggplot too. So I say, plot for me, you put the syntax is you put the name of the data where R is going to find the information. So data one, now AES, it means that these are the things that I want to plot. So you need to put this also there. It should be there. It's according to the syntax. So now I say X is operating expenditure, Y is operating revenue, and I put them in brackets. So this bracket here applies to this. So I'm telling from here to here, I can finish my plot. I'm telling R to go and plot for me X and Y, and X is operating expenditure. So it means that R will search for operating expenditure in data one. It will also search for operating revenue in data one, but it will allocate operating expenditure as X and operating revenue as Y. That's what R will do up to this level. Then you put plus. This plus is saying that now you are adding things. It's not just the plotting, but maybe you want the titles, you want the, So I'm saying R geometric geom point. You also put as it is here. So I'm telling R to color my point. And how is it going to color it? I say color it according to ID. ID is also the variable that is in data one. And I also not only want it to be colored, but I want the points, these points that will be in this plot, the point to have a certain size. So what is that size? The size will be according to operating expenditure. What does that mean? It means that if Johannesburg, the operating expenditure is 3, and Matatiele, the operating expenditure is 1. So the size of these points will be, of the point in Johannesburg will be bigger than the size of the point in Matatiele. So that's what I'm telling R. And alpha 0.5, okay. I don't know what it does, but I also normally put it like that. So you can run. Observe what I'm doing. I'm going to run this. I run it. You observe that nothing has changed. What has changed is just in the console, you have the same function repeated here in the console here. It is here, as we can see. Why? It's because I didn't tell R to show the plot. I just told R to do the exercise, but to put the outcome in this object that I've created. So now if I want R to show me what I've created, I come here, I say, can you plot for me? So using print. In this way, we are using now print. So R will print for me this. Let's see. You see, it takes time because you see, it has printed a graph. You can see in this bottom right panel, there is a new graph. And the new graph is better than the one that we had because you can see there are points which are bigger and the points that are smaller. If it's smaller, it means that the operating expenditure is smaller. That's why it's small. If it's big, the operating expenditure is big. So the legend is there. You can see yourself the legend. 6, 7, 8, 9. You see. So at least here we've managed to do something which is meaningful. And the ID also, they are there represented because ID are given by numbers. You remember the ID? Let me go to data one. I'm in the console. I say ID. I click ID. You see ID are given in numbers. So I understand that ID, because they are numbers, I'll give the, but normally they are the names of the municipalities. If we had changed to the names, this was going to be in names also. So I prefer this one so that we don't confuse ourselves. So ggplot you can also use ggplot to do the plotting. So we've done one. So let's now plot differently. In this case, we are doing the same, still GD, ignore Windows, ggplot, but in this case, I'm not taking R.
Sorry, Dr. Clement, can I ask
Yes.
you a question? Yeah, how can you?
Yes, you can.
Yes, this graph, can it be copied to a Word document, or can we copy it to a Word document?
Thank you very much. Nice question. Yeah, you can. Okay. Let me go back. Can you see where my cursor is? I'm shaking it in the bottom. So you see down here, there is zoom. You can zoom this to enlarge it. Okay. And after that, there is export. Okay. You see export?
Yeah.
Yes.
You click the drop. You can click the drop. There is an arrow there for the drop list. So you can save it as an image. You can save it as PDF, or you can copy it in the clipboard. If you are working in a Word document, you can just click here, copy to clipboard. It will take it and you go in the document. Or you can save it as images, or you can save it as PDF. Let's save it as PDF, for instance, or image. I like the image. When I click save, you see it gives you the option. Even here, you can increase, you can change things, even the width. Let's say we want to increase, because this is the default. Let's say we want it to be 700. 700, it will increase to 700. Let's say updates. You see it has changed in terms of the width. Because this is very important. That's why I like this. I like this because I remember there was a journal where we wanted to submit a paper. Then they gave us instructions to say, if you are submitting the figures, the maps, they told us that the maps they gave us the specifications. So we had to come and play around with this so that we comply with those specifications. So I like these images because some papers, particularly when we start talking about maps, you will see that it becomes even more relevant. Some papers, they give you instructions, so you need to do that. So thank you for asking that question. It was very relevant. Thanks a lot. So I'm not going to save it. I'm just going to cancel it. So you can save it as PDF, or you can just put it to clipboard. So yeah. So now I'm going to let me delete it. Don't worry, because it's there. We've saved it as in GD data one. So let me delete it. Let me now create another one, but this is the one that I'm going to create. But this one, the difference is that I'm not allocating, I'm not assigning it to it. So what will happen when I click on this, it will will show directly in the plots panel. But I want you to note this. There is a difference between this one and this one. In this one, I've added this element. This is a new element that I've added. So the smooth, because this is a scatter plot. I want the data, the scatter plot to be, I want to add a smooth to see that relationship, how it is, particularly if I can put a straight line. So that's the difference. So let me run it. When I run it, it takes a little bit longer because it's doing the exercise. You see the difference? Now there is the line, the blue line with the envelope, because it is smooth, showing you how you can put your straight line to see if it's, but by looking at it, there are some outliers, many of them, because this is far, but it's okay. You can see that there is a straight line. So we've done that. And let's take maybe if there is a question, I can take one question, then we take a break for 10 minutes, we come back and we continue where we left.
Just to make sure that we don't lose what we have done so far, what do we do? Do we click save?
We don't, you just leave it as it is for now.
Okay.
Just leave it as it is, yeah.
Okay.
unless if you have a power shortage, then you will lose things. But there is a way of saving it. Can you go to the script panel where the script is in that panel?
Yes.
You see on top here, you see file, edit, code, view.
Yes.
Where I'm pointing, but now go down. When you go down, I'm pointing somewhere where it says save. When you click on save, you're gonna only save the current. But when you click here, save all open document, it will save everything. Sometimes you can use that, but this will apply to the script that you've opened. But if you want to close R, we'll see you also maybe today. If you want to close R, to exit R, R will always ask you a question. Do you want us to save the work? Then you can save the work. Yeah.
Okay.
Yeah. So that's why I'm saying leave it for now, but we'll come back. So let's take a break of 10 minutes. We come back at 11:15.
Thank you.
Thank you, sir. How to manipulate data in terms of you can select, first of all, how you can import data, how you can save data, how you can manipulate data by removing, by checking whether there are missing observations, and how you can select data. Let's say you've got a lot of data and you are interested in 2 or 3 variables, and how can you do that in R? And we've seen how we can plot simple plotting in R. So now, what we want to look at, so far we didn't even say the data that we were collecting, is it spatial data or not? Whereas this workshop, we are interested in spatial econometrics. So we need to talk about how can you download, or how can you import, or how can you read spatial data. But before that, there is this one element that I want to say. You remember I was talking about windows like this one. I was saying that we can create plot by first clicking on windows so that they are out of the panel that you have for plot, so that you can, if you want, there are things that you want to work on, you can work on. So if you want to close them automatically, all the windows that you've created, there is this function. Remember I told Prof. Ngepa that you can click on delete and Prof. Eta. So that's it. You can use a function. You just say div dot off, it will close that those windows. So you will do it if you've got the script. So now we are looking at, remember, let me come back to this data in class 1. You remember data 1 that we had for municipalities, that the one that we just used now? We said you can look at the class of a data set by using the function class. Let's say class. So it's a data frame. This is a normal data frame, but normally spatial data, you can have not only because you need location, you need polygons, you need, like in this one, when we click on names, let's look at what come out. When you click on names, they are only the normal variables. But what if I want to do a spatial analysis? Because they are municipalities, it means that they are areas, but I'm missing some information. I'm missing information related to the location. Remember, we talked about polygons. So location can be presented as points or as polygons. And we said we are going to work with polygons or points. So this data one is missing that element. So it's not yet spatial data. Although we know that municipalities are areas, but we don't have that information. So it's not spatial data. You can't do spatial analysis with that unless you add that component. So sometimes, this is maybe responding to what Prof. Ngepa was saying. Sometimes you don't have data as a spatial data. In which way? Where you have the attributes and the location. But it's up to you, the researcher. You can find the attribute somewhere else and the location somewhere else also. Then you merge the two so that you create your spatial data. Like when I was working on the municipalities, that's what I did. So I had to collect the attributes, then the location, and merge them, so that I can create spatial data. So we are going to do that now. So I don't know, let me check in the package that we've installed if there is this package. Okay, there isn't. So it means that you need to download this package if you don't have it. So I'm going to write something here on the console so that we install this package, because if you don't have it, you will not be able to do that. So can you all type what I've written there? Or I can put it in the chat so that we can just copy it. Let me put it in the chat so that we can, let me stop sharing and look at the chat. And yeah, let me look at the chat. So I've put that function in the chat. So you can just take it and copy it on the console. It will install. If you don't have that package, the package is called RGDAL. So you can copy it, check the chat and copy it in the console. So it will install that package for you. I thought I had put it. Can you all see it? Hello? Can you see it?
No, I can't see it on my side.
Yes,
it's in the chat. Okay. Go to chat box. I've put it in the chat box.
Oh yeah.
Yes.
Yeah, I see.
Okay.
Yeah, I can see.
Okay.
It.
Copy it as it is. Then you install it. It will install that package because we need that package to read the shapefile.
Okay. Thank you.
Okay. So while you are installing it, what you will do after you install it, you will do library again so that you can call it. So we have what we call spatial data can come here, when I say spatial data, I'm just referring to, it could be spatial data including location and attributes, or it could be just location. So excuse me, when I say spatial, it could be location and attribute, or it could be just location. So the most important thing to note is just location. So whether there is no attribute, we'll still call it spatial for this workshop. So we call it spatial data for the location. So like the example that I've given you, the data one for municipalities, there is no location. So that's why it's not spatial. So we need to go and check the spatial. So the location of municipalities. So they come in shapefile. They call them shapefile. Shapefile, when you open your, maybe I should stop. First, let me stop sharing, then I will show you what a shapefile. I go to the document so that I can show you what are shapefiles. Excuse me 1 minute. Just 1 minute. Okay, I'm almost there. Now I can share my, okay. You can see the folder where we are all working. We've got, if you've got practical one, forget about the rest, but just practical one, you do have these files. When you go down here, you see the file called zfadmin3.cpg. And you can go down, apart from the Excel, you have also others. So these are what we call shape files. That way the information in terms of the polygons, and we've defined polygons what they are. So that information is contained here in these shape files. And you can't open this shape file unless you have a GIS and even R, you can open it. So when you want to, what is the three, there are five, apart from the Excel, there are five. But the most interested one, look at the extension. You have SHX, SHP, and DPF. These three are the most important. So it means that when you are calling a shapefile, these three should be in the location where you are calling a shapefile from. If they are not there, if they are missing, there will be an error. So the three are this one, the extension, just look at the extension, DBF, SHP, and SHX. What we are normally calling is this one, SHP, but because each of these contains a particular information. So when we call that in R, R will take information, the pieces of information from this one, from this one, from this one. So that's why these three, at least they should be there. So that's why I wanted to show you this. And this one, we call it shapefile. In shapefile, we do have polygons, or you can have points. Like in this case, it will be polygons for municipalities. So let me stop sharing, and I want to share now this one. So once you've downloaded or you've installed that package, you need to call it. So with library. So now I'm now calling the shapefile. You remember that shapefile was called zfadmin3. So I want to call it in R. And this is how you call it. You use this function, read OGR. So you use this function so that you are able to call that.
Sorry.
So you
Sorry, can I ask a question? A quick question.
Yes.
Yes. The shape files, where did you get them from? Is it that you use R to create it, or you use
no?
GIS?
Yes, I will come back to that. I got it from the internet. There is I will show you that that website.
All right, thank you.
But like in South Africa, you can get it also from municipal demarcation board. Yeah, okay. You can, because in the municipal, because they are responsible for trying to demarcate municipalities, so they always publish the shape files. It's free of charge. These ones it's free of charge, so you don't have to pay for it or what.
All right.
At least this one we've got it here in South Africa.
All right, thanks.
So I will show you that website. You will remind me if I don't, but I will make sure that I show you.
All right, thanks.
So the shapefile, yeah, thank you. So this is the function that you read the shapefile with. So like we've been saying, if you are reading a shapefile, you need, or if you are reading, or you can allocate whatever you are doing in R. So that's what we've done. So I'm telling R, read the shapefile in my folder. So this, you need to respect this syntax. If you are not on your, so if your work session is not where your data is, it's very complicated. It's the funny thing, you need to put the slashes, and so that's why I prefer to work on my folder where I'm working. So that becomes easy. Even the syntax becomes easy. You just put these quotation point, comma, quotation again, you put the name of the shapefile without extension, because R will understand, because as I told you, those 3 extensions, R is taking the pieces of information from that and collect. So you don't have to put an extension in this case. As long as the 3 are there where you are sending R to go and collect. So I'm going to run this. Observe, you can also observe here, there is nothing called here mini shape. So it will be a new object that I will create. So let me call it, I will call it. It takes a little bit longer, but not that longer. It depends on the number of polygons that you have. Let me call it, I will click on run, and it will be here. So there is an error. You know why? It's because I didn't click on library. So that's why it says we don't know this function. So I need to click on R to library to run it first, to call it. So I'm calling it. Even you, when you call it, you'll have this thing. Now that it's here, let me click on it. I click on it. You see now there is no error. It's now working. So you always have to call the package. So it's still loading. When it's done, you will see the sign of great will appear here. So now it's done. So I do have my shapefile now for municipalities in my working session. You can even check there it is. Check this panel where the data is located. It is there. So you can, as we've done with the rest of the data, you can check the class of any object in R. Like mini shape, we need to check also the class. So you click on, you run class mini shape. You see, please follow me clearly here because it's very important. You see, it gives you the name of that, not the name, but the class. It says spatial polygons data frame. Very, very important. It's different from what we were dealing with, which was data frame. This one is spatial polygon data frame. So we do have the spatial data now. So you've done the first input of spatial data. You can even look at, so don't worry about this, it's just telling you the package which was used to create this. It was the package called SP. So don't worry about this. The most important thing is this. So it is spatial polygon. So now you can click on structure to see how data or the information in mini shape, which is a spatial spatial polygon data frame, how the information is stored there. You see, it's still running. So it means that it's impossible. It's long. You can see that you'll have a long list. It's because it's a shape file. Shape files, it's small pieces of information, and it's even difficult for someone to read. So don't worry about it. You can also check the names. You see here, I'm checking the name. You see names, I say mini shape data. You see, I'm using arrow bars now. So I'm saying, give me the name, because let's come back to this one, class first. It says spatial polygons data frame. What does that mean? It means there are polygons, but there is also a portion of data. So there is also an information which is like the normal information. So when I say, give me the names of mini-shape arrow bars data. So I'm telling R to give me the names of the variables for the mini-shape, but the component of data, not the polygons. So that's how you do it. You can click there. So it gives you the names. So these names are for the component of the data, which is contained, data frame, which is contained in the mini shape. So you have the ID 0, IS 0, name 0, and so forth and so on. You can even go and check them. So I told you about the names. You can say call names or names. It's the same. So let's say you want to check, because let's go back to this one, names. Sorry, I'm just trying to, yeah. You see, we've got this name, for instance. This is a variable. So now I want to see, like we've been doing with data, to say if you want to see what is contained in a variable, you can just put the name of the data and $, then the name of the variable, like what we discussed with Prof. Eta. The same applies here. You see, now we say mini shape, $, and the name of the variable. So we can run this. You see, it gives us the names of the variable, as you can see. So they are Matatiele. So it's the same names that we have also in the data one. So the same. So you can also check the dimension. So it says it's 232 and 15 variables. So this is the parts of the variable. So you can also plot. You see there is a plot here, as we can see it on the screen, but you can also plot mini shape. What happens here is that R is very intelligent, because the structure of mini shape is a spatial polygons data frame. When you tell R to plot, what happens normally is R passes, because R investigates, first of all, or evaluates the structure or the class of the object that you are asking it to do something. So R evaluates, and R discovers that this is not a data frame. So this is a spatial polygon data frame. So what R does, because plots is just for simple things, it's for data frame. So what R does, R takes that information and passes it to a function which can plot properly a spatial data polygon, whatever. So that's what R does. So let us plot this. So we are plotting this, and we say border, because we know that it's a polygon. Polygons, they do have borders because they are areas. So now we are telling R, you are going to color the polygons in gray. So R need to show us where each polygon stops and where it starts, you know, so that we know that, because they are polygons, we need to see the borders so that we know that they are polygons. Otherwise, it will give us the map of South Africa without those borders. So let me click on it and let's see what happens. And you can see already that it has, first of all, deleted the plot that was there, and there is a new plot now that is here. Can you see the plot on your side? It's building. You can see it on my screen. You have on the right hand side, you have the plots of polygons. These are polygons. These are municipalities. This is a polygon. Like Cape Town is somewhere there. And maybe let's change the color. Maybe because this one is not good, let's change the color. Let's say a blue, so that it is showing properly. So if we change the color, I think it will show properly. I don't know what's going on. Yeah, blue is there. You can see at least, oh yeah, still the same. And Lesotho is here. So you have these. So you can plot also with using spatial data, spatial polygons. So this is the first type of data. So far, we haven't done anything. We've just called this data, but you need now to merge them so that you can use the information that we have in data one with the location. So we'll see that later. But for now, I want to go to point data, because remember we discussed the types of data. This is plot, this is polygons. Now let's see the point data, and you will see the difference between the two. So the point data is, when you look at, let me check. We are going to use a data file called MUs. You see this? So we are going to use the function read RDS. There we're reading RD, we're reading OGR. This is RDS. So let me click and see what will happen. So I've already got the data. Check on your side. It's because there is one file, one of the things that we've downloaded. I think it is, let me check it. It is this, it should be this one, SF. SF, does, when you call it, it's because it's in the session, it has got already the data itself. So that's why it's like in Stata, you do system, yeah? System use. So it's the same, because we've already called this package SF. So MUs is part of the package, so you don't have to worry. No, I'm wrong. It's not like that. It's because MUs is part of, when you check the folder called practical, MUs is there, my MEUs is there. So now it's a data, but it's in, this is another format of data, of R data, RDS. Remember we said RD data, so there is also RDS. So RDS is also data for R. So you just call it, because it's in the folder, it is there. So let's plot it. Or you can check the class. When you check the class, it tells you that it is spatial point data. Whereas when you check municipal minishape, it says, sorry, minishape says spatial polygon data frame, and this one says spatial point data frame. So they are different. This is point data, like I've explained what is point. So point are just point, longitude, latitude, longitude. So they are not given in terms of the rings, which are closed. And spatial polygons are point, but which are sequenced and closed. So this is, minishape is polygons, and my MUs is point data or spatial point. So you need to know that difference. So the other ways we can also check the names. You can see that there is also a component of data which is in this my MUs, which is cadmium, copper, lead, zinc, and all those kind of things. You can also plot it. You can first look at dimension. It says there are 155 rows or observations and 12 variables. The data component part, data component, not the point, the data component. So you can also plot it. I'm going to click on plot. It will do the same. R will say, oh, this is a spatial point data, and it will pass it to the function that normally deals with spatial points. So you click on run. Have you seen what has happened? So the plots, we've changed the plot. So it's no more South Africa with the polygons as municipalities. This is something else. You can see these are points. They are not linked. That's what we were saying. They are not linked. You can see they are points where you see the cross. So it means that this is longitude, latitude. They just give you the point like they are. So these are the points, and that's how points are given. So you see that difference. I don't know if there is any question so far. Let me stop sharing. Is there any question? There's no question. Hey, I'm surprised. So now, because there are no questions.
It means we're doing well.
Okay, thank you very much, Prof. So now what I'm going to do, I'm going to ask you to an exercise. You will do it on your own. Then when we finish, we go for another practical. So the exercise is, it's down there on the script. So I'm asking you to load the data set, which is called Columbus. The data set is on your folder. It's there. So you need to check, it must be there. Let me check if it's there. Check first. Can someone check in your folder if you have Columbus? It seems that I don't see it here. Can someone check? Do you have Columbus?
Is it under practical one?
Practical one, yes. Maybe I made a mistake. I don't see it here.
There is CS. Does it mean CS?
No, it's not. It means that it's not. So let me check what I can do. Yeah. Don't worry, I'll find a solution now. I thought I put it and it was not there. Okay, I see. Oh, yeah. Where did I put it? I think I put it in a wrong. I should put it in a wrong. I should have put it in a wrong. Let me check on practical 2. No, there is nothing in practical 2. Practical 1. Okay. We're supposed to do this. Okay. Okay. So it means that we are not going to do this exercise. We'll do it later because I think I forgot to put it there. Let's not waste time. Let's just forget about it, but we'll do it later. I'll share with you the folder so that you can do the exercise. So I forgot, I'm very sorry, I forgot. I thought that I put it there, but it's not there. So we are not going to do the exercise for now, but I have to give you first the folder so that you are able to do it. Okay, let's jump that one. We'll do it later. So we jump 5, which is exercise. Let's go now to merging. How do you merge your data? Remember, we have now mini shape and we have data 1. They both relate to municipalities. So how do you work with them? First of all, check the dimension of mini shape because they should be, in terms of the rows, they should be equals. If they are not equals, it means that there is a problem because they should correspond. Rows represent municipalities in this case because they are observations. They represent municipalities. So the number of municipalities in the shapefile should be the same as in the data frame. So how do you check that? You check first dimension of municipalities, or you can check this way. If you don't want R to give you the number of columns, you just say dimension, municipal shape, you put bracket 1. It means that give me just the first, which is rows. So it will give you the rows. So you can see it says 234, whereas dimension for data 1 Are you following me? I'm working on the console. Whereas dimension for data one, when you click it, it says the rows are 2,232. So there is a short of 2 municipalities, if you can see. So which means that if we merge, we are going to make a mistake. It will give us an error. We are going to lose that. So what I normally do, don't worry about this one. You will read later. I've done it myself. So I've eliminated rows number 39 and rows number and these rows. So I've eliminated them because this is the one that is missing in the data one. So I'm going to do it for you. Even you on your side, just click it, run it without any problem. It's just to merge everything. So I've run it. So when you run it now, if you say dimension municipal shape, mini shape, you will see that it will be, no. Or mini shape 2, yes. Dimension mini shape 2, it will be 232. Can you see that? So it means that mini shape 2 correspond with the number of rows in the data one. But the other challenge, it could be the number of municipalities can be the same, but they are different municipalities. How do you know? So it's an exercise that you need to do on your own, maybe by checking whether the names are corresponding. But when we merge, if the names are different, R will tell you that the names are different. So I'm confident that R will do things for us properly. So follow me clearly here. So we are going to use mini shape 2, not mini shape. So mini shape 2 because it corresponds with the number of observations that we have in data one. So the first thing that I need to do, because mini shape is a mini shape 1 is a polygons or spatial polygons. So I can create what we call coordinates. So I can extract the longitude and latitude. This longitude will be the longitude of the centers. We call them centroid longitude. Remember the mini shape, those are polygons. So it will take the center of each polygon and gives you what we call longitude and latitude. So there is a function in R. This function comes from SPDF or SP, and that function is coordinates. So you just put coordinate and you put the name under brackets of the object, which is a polygon or spatial polygon, then the function will just do the things for you. So this is the function that I'm talking about. Coordinate is here. So coordinate. So this function will look at this object, mini shape 2, and extract the longitude and the latitude for the centers, which we call centroid. So that's what it will do. And once it does that, it will pass them, or it will pass that information to a new object that I've created called chord. You see? So let me run it. When I run it, you see, it is on the click of the button. So you can check codes. You can say you can say class of code, for instance. What is the class? I told you that any object in R, you can check its class. Class of code, it says it's a matrix. So what this function of coordinates does, it creates a matrix array of coordinate. So it gives you let's say it will give you the polygon name, then it coordinates in terms of longitude, latitude, coordinate, longitude, latitude, and so forth and so on. So that's what it does. You can see it if you want. You can say code, just click code, sorry, code, sorry. I don't know, it's refusing. Yeah, you see, when I click code, it gives me, it's a matrix array. So it means that for 0, this is the coordinate of this municipality, which is sitting at 0 as ID. For this municipality, these are coordinate also. So this is longitude, latitude for the centers. So that's what it has done. So once it has done that, what I'm going to do now, I hope that you are following me. If there is any question, please ask, because if you get lost, then there is a problem. So this function.
Sorry.
Oh,
Yeah. Sorry.
Yes. Yes.
Can you just repeat what you did with code? I think I missed
with
that.
code, yes. I've run this function.
Okay.
These functions, the purpose of this function is to tell R to say, go and search in this object. And because we know that this object is a polygon, or it's an object that has got polygons. So when we put the function coordinate, we are telling R that extract the coordinate for the centers of each, polygons that we have in this, because mini shape is a spatial polygon. So that's what we do. So we run this function. Once we run it, we say, take that information, that outcome, pass it to code. Code becomes a new object that we've created. So it has created. So now if I want to see things that are in code, I can just click code, and things that are in code will be printed on my console. So I just click code. So it has printed everything that I had here. And we know that the first array is longitude and latitude, and this is just the IDs. So that's what it has done for me. Yeah.
Thank you.
And yeah, thanks a lot. So don't worry about this. This one I've done it. I'm not going to explain to you now because I've done it on my own so that I can eliminate some things in my data one. So you can close your eyes, but you can just run it. As you can see, maybe I can explain. Because we've done this previously. You can see data one. You know data one, it's the data where you have municipal information. And we put this bracket and there is comma. Can you see the comma? Comma, and they say C. Then we have the numbers here. And the numbers goes from 3, 5, 7, 8, 9, 11, 12, 13, 14, 15. Then there is these 2 points. What does that mean? It means that from 15, it will be 15, 16, 17, 18, 19, 20, up to 22. So instead of writing all of that, because they follow each other in a sequence, I just put this to R will understand that it's 15, 16, 17, up to 22. So this, we've done it. This is a selection. So I'm telling R to go and select only these columns because we put comma here. We are not interested in the rows. So we are saying that in data one, go and select for me column 3, 5, 7, 8, 9, 11, 12, 13, 14, 15, up to 22. So select only those. Which are those columns? We can see them. Because I know them, I know their names, that's why I did this. So, but for you, what you can do, you can come to names. Again, you see data one. It will give you the names of each column. So we've got 17, 18, 19, 20, 21, 22, 23, 24. We've got 24 columns. So what I'm asking R here is to say, select me column 3. What is 3? 1, 2, 3. So it will select this. 5, it will select also this. 7, it will also select this. 8, it will also select this. 9, it will also select this. 11, it will also select this. 12, it will select this. 14, it will select this. 15, it will select this up to 22. So 22, 17, 18, 19, 20, 21, so up to this. So this one will not be selected. So that's what I'm telling R. Go and select for me these. I could have put the names of the variables, but it's the same. R will select for me these columns because I know them, what they represent. So, but because I don't want to lose data one, because if I put data one here, I say, instead of my data, I say data one, it will override. So this new function that I'm executing will override data one, and I will lose the information that I had already in data one if later on I want to use it. So that's why I'm creating a new thing. I call it my data. So when I run it, there it is. You can check now the names of my data. You can see that they will be the same as in data one, but the difference is that data one will have more variables than my data. So that's what I've done here. You can see here they are 17, 18, 19, 20, 21, 22, 23, 24. But here they are only 17 because they stopped on bachelor. You see, that's what I've done. So I've just selected the variables. Why did I do that? It's because that's what I wanted to use. I didn't want to use other variables. So instead of wasting my time and my space, I just select what I need. So we've done this. So you can run that. So now what I want to do, I can now create what we call spatial point data frame. You remember my use, let's say class, is it my use? Yeah, my MUs. You remember my MUs, we said it's a spatial point data frame. So I can also create a spatial point data frame from the information that I have now, which is information. You remember I've got Minispo or Minishape 2. In Minishape 2, I have created cohorts, which is the longitude and the latitude for the centers of each polygons. So I've got points. Those are points. They are points because they are longitude and latitude. They are not linked to form a polygon. No, I've just extracted the points. So they are points. And now that they are points, I want now to create, to merge those points with my data that I've created so that I can create spatial point data frame. So it is possible to create spatial data point frame on your own if you have location information and the data information. You can create that. So that's what I'm doing now here. So follow me. If there is a question, just speak to it because I'm not watching the other screen. You just raise your, you just speak and I will stop and listen to your question. So now I'm creating my, what I'm calling my data point SPDF. It's just to say it's spatial point data frame. And the function is spatial point data frame. Remember, I told you that if you don't understand, like this one, it's a function. If you don't understand it, even coordinate, you just put comma there, what is it? Question mark, then you say, what is coordinate? R will give you L, and you read it and you will understand it. So that's why we are not putting it here. So I say spatial point data. So now I put my coordinates. That's where my points are located. Then I also put my data. So they will merge these two data and R will create a spatial point for me. So let me click on it and run it. I've run it. So it means that I've got now my spatial point data, which is called my data SPDF2. Let me prove to you that I've got it. Let me plot it. If I plot my data SPDF, you see on the plot side, it has given me the points, but if you can check properly, the shape is like the shape of South Africa, but there are no more polygons. These are just point data. So I've got my point data already here. They are there. So they are given in points. So you can create if you have got location. So this is the first example of creating point data. So that's one. You can also merge. You can also merge polygon and the normal data so that they become one data. We are going to do it in the following function. I'm going to create my data one. So far I've got my data and my data point SPDF. Now I'm creating my data one. My data one, I'm saying merge. You can create, if you want to investigate what is merge, follow the same principle. You just put question mark and merge, it will tell you what is merge. See? So now I'm putting the first element that I want to merge, which is my mini shape 2. Remember all the operation that I was doing to eliminate the 2 municipalities that were missing. So now mini shape has got 232 municipalities. So I'm in the safe. Then I put the second object that I want to be merged with the first one. Then the syntax is by X. X, you can understand, is the first one. So I'm saying, which is the criteria that you are going to use to merge the 2? So when that when R looks in the first element, it should look at a certain variable to say that variable should be equal all the elements that are in that variable. So all the rows, they should be equal to the rows on the second variable. Maybe let me explain properly. If in the first element, it was the names of the students or the student numbers, you start student number 3, number 4, number 5, number 7. When you go also in the second object, which is my data, you also check again student numbers. So those numbers should be equal. And equal does not mean order. It just means equals. So they can be in different orders, but they should be equal. So it means that if there is 3 here, there should be 3 there. If there is 4 here, there should be 4 here. If there is 1 which is different in the 2, it will not match. It will request you to say there is 1 which is not matching. So there should be a match. That's the word. So whatever is contained in that variable that you've chosen, and variable here is the column. So whatever is contained in that variable should match with the same name of the variable in the second. So that's what we've done. By X, we say CCA3. So there is a variable called CCA3 in my mini shape 2. We can check it. Names, mini shape 2. You see the names? There is CCA3 is here on the 11th position. So we can check also in my data, the names, my data, to see whether we have. So CCA is the first one, is also here. So what I'm telling R is say they should merge these according to this criteria. I know in Starter you do the same, but it's a different logic, but you do the same thing. So it will match. If they match, it will add it. So we are going to do it now. So let's do, we click there. We are done. So we do have now my data one. Let's look at the class of my data one. When you click on the class, you see now it says it is spatial polygon data frame. So now it is, I've got all my data. I can do now the spatial analysis because I've got the location. I also have the data in terms of attributes. So everything now is okay. So now I can do the spatial analysis. For instance, if you want, remember I told you that in spatial polygon data frame, there is the component of the spatial, there is also another component of the data frame. Sometimes there isn't. What is important is just the location. But in this case, we've added that component so that we can do the analysis. But it can also happen that you don't need to add them. You can do things separately, but when you are calling the function, then, but it's very complicated. I prefer this so that when you do the analysis, at least it's easier. But we will do the exercise. There will be one exercise where you don't have to do that. So you'll see. So now I want to check the data parts of this my data one. So I just say, name for me what is contained in my data one, but in the data component. And it names for me. And if you check properly these names, they are the same as the names that are in data one. Let me name data ones. You can see that almost the same. CCA, we do also have CCA3, ID0. It's a new one because it comes from the component of the mini shape, but everything that is here should be also there. So that's how you can merge your data. That's how you can merge your data. So we'll jump this. We are not going to do this because of time. We are going to jump this. So let me close this practical with saving. Now that you've done all your things and you are done and you want to leave now, so that tomorrow or another day you come and start working. So assume that you've done all this exercise, you've cleared your data and you've done this. Although you've got the script, you can still run the script, but it will take time again. So you can, instead of just closing your things and when you come the next day, you'll work on your data again, you can save whatever you've worked on. So you can save. Yesterday, I showed you how to save using R data. So today, I'm going to show you how to save in RDS, sorry, save RDS. So you can save RDS, the function is here. You save, similar like we've done yesterday, but here it's save RDS in plural, in capital letters. I don't know where plural is coming. Save RDS, capital letter. Then you put here the name of the file that you want to save, like here my data one, which we've just created as a spatial polygon data frame. Then you say file, and here you are just putting the name that you want it to be saved. So when you come later, it won't be my data one, it will be this name that you need to call in your session. So you can save it. So let me save. I save, I just run it. It takes a little bit long, maybe 5 minutes. No, not 5 minutes, some few seconds. Yeah, it's done. So if you click on your side and go and check in your folder, you will see that this data is same. You will have a new data on your folder called my_data1 RDS. So let's say when you come back tomorrow or after tomorrow, you want to start from where you left on. You will just call it. But you remember with R data, we were saying load. So to load the data. But with RDS, you read. So you just tell R, read RDS, which is a function, and you give the name of the function, of the folder that you want R to read, and you put the extension. So R will go and read it for you if it is in the folder. So you see now the difference is here. When it reads like this, it just read it. It does not, so that's why I prefer normally to give, yeah, I will show you later. Maybe let's stop here. So you can read it in this way. So let's stop by here. Let's do the practical number 2 up to 1. Then we take break. So I don't know if there is any question before we go to practical number 2. Number 2 will go very fast. There's no question. Thank you very much. So allow me to to open my practical number 2 because it's somewhere there. So in practical number 2, what you need to do now on your side, remember now with your R, let me show you, maybe by showing the screen, because they are in different folders. I don't know if they're in different folders, yes. So what you need to do, for you to change, you need to change the session, the working directory, where you are. So let me share the screen with you so that you see. Can you see my screen? No, it's not sharing. Okay.
Not yet. Oh, it's
yeah, now it appears. Can you see it now?
Yes.
So you need to change now your folder because we are going to practical 2. So you need to change the folder. So I've done this on purpose so that you know how to change if you are changing things. So what you do is very simple. You just click on session, on top there where I've clicked, there is a list that appears there. So you go to set working directory like we've done. And there is also a list. You choose directory, you click this one. It will lead you to where you are now. It will lead you to practical 1. So you need to go back to day 1 and choose practical 2 so that you set everything in practical 2. So I'm doing myself the same. So now I am in practical 2. Very simple to change. Is everything okay?
Can you just repeat that again? Session.
You go to session.
Okay.
Choose set working directory. Then go down there to where they say choose directory.
Yes.
And you click it. When you click it, it will lead to you to where you are now. So in your case, it will be in practical 1. Then you go to day 1. You go like backwards, day 1. Then you just click on practical 2 and open. Don't choose anything. Just click on practical 2. It will be an empty thing. Just you click open. So when you open, it means that you are there in practical 2. Another way of seeing or to confirm if you are in practical 2, you go in the console, you say get working directory. So get WD brackets, you just click enter. It will tell you that you are in practical 2. It should tell you that you are in practical 2. The last slash should be practical 2. So now we are in practical 2. So because we are in practical 2, you need to open my lab 2. How to open my lab 2? My lab 2 is in your practical 2. It is given, it was provided with the practical 2. So you go to check. Can you please check? There are 2 ways, but I prefer this one because it's simple. So you go to where I'm putting my cursor there. Can you all see where it says open, where there is this sign of open? Can you see?
Yes.
Can you see? Oh, yeah. You click this one, it will open the folder where you are or the directory where you are. When you open that folder, you see there is my lab 2 and my data and data mats. So don't choose anything. Just cancel it. Don't do anything. Cancel it. So before we do that, let me ask the question. Is everyone okay with, I want now to clear this panel. I want to clear everything that is here. So I'm going to clear it.
Yeah, perhaps before you go there, when I went to click open, it shows my lab 1R and clear list.
Clear list.
Yeah. Does it
let me
mean
check.
I made a mistake somewhere?
Let me check.
Okay.
Were you in practical 1?
What happened was that
yeah.
when I saved, I saved under practical 2.
Oh, okay. You should have not saved, but it's okay. But what is important is that these three things, which is my underscore data 1 and my lab 2 and data math 3 should be there. If they are there, it's okay. The rest, you can forget it.
Okay, let me just check.
Let me show you. You can see it from my side.
Okay, let me check. Okay.
Do you have this? Check on your side. If you have this, it's okay.
Let me go to my. Let me do this. Practical 2. Let me just confirm to make sure that I have exactly what you have. Yes, I have.
Okay.
I have them.
Okay, no problem. If we have them, it's okay. That's what matters for now. So,
okay.
What I want to do, I want to share with you the screen again, but I want to clear everything here because we are starting from a new slate. We've already saved our data, and I've saved it for you because that's what is in your practical too. So even if you didn't save it, don't worry, it's in the practical too. So I want to clear it. So I'm coming here where I'm putting my cursor there. There is a broom also. You can see it. If I click here, I will clear everything. Let me click on it. It even asks me, are you sure you want to remove all objects from the environment? I say yes. So I remove everything. I remove even the plots. So yeah, it's okay now. We are starting on a clean slate. So we are assuming that it's a new session. It may be after 2 days or after a week. You are coming back now. You want to do things from where you left them. So go now to this panel where we have our script. Click on that open thing. Can you see it where I'm putting my cursor? Can you see it?
Yes.
Okay. You click it. Then you choose, in practical 2, you choose my lab 2. You just select it and open. So you will see that you will have 2 scripts. You will have my lab 1, which is not activated, but now it will be my lab 2, which should be activated. You can even see from my side that my lab 2 here, where I'm putting the cursor, it's now activated. The rest is not. So now it means that I am in my lab 2. So forget about this thing. I told you that this thing was used so that we can select. So forget about it. Don't use it. You can even put the hashtag in front of it so that we don't use it.
Yeah, I think mine is still showing my lab 1. Eh? Maybe I made a mistake somewhere.
No. Where did you go? Did you select my lab 2?
Okay, I go here.
Yeah. Select my lab 2.
It shows my lab 1, unless.
So you didn't change you need to change your folder. So, Prof, follow me.
Okay.
I'm doing this. Go to session, where I'm clicking session.
Session, okay.
Click on session. Then you will see set working directory.
Okay.
Then on the right, choose the last one, which is say choose directory.
Choose directory. Okay.
You click on it. You open it. What does it open? It opens the folder where you are now.
Okay, let me just do it now. Session, then I choose directory, and then it says choose practical 2.
Yes, you are in practical 2, so it means that you are in the right. If it says practical 2, you are in the right folder.
Okay.
So you can cancel it. You are in the right folder.
Okay,
unless if it says practical 1. If it's practical 2, you are in the right folder.
Okay, let me cancel it. Okay.
So when you cancel, now click the open, that thing, the yellow thing.
Okay.
When you click it, you should see my lab 2.
Okay, let me try. Let me try open. It is actually saying my lab1.r.
Oh, it means that you made a mistake maybe when you were saving your folders. You should check where your folder, your MyLab. Okay, let me do this. I'll put, don't worry. You can be where you are. Just be where you are. What I will do, I'm going to put this in there. So I've copied everything. The 3 folders that I have in, let me put them in, it's not, let me, because I want to share it with you on my, in the chat so that you can just copy them and put them there. So give me 1 minute.
Okay.
I'll do that.
Okay. Thank you.
Okay. Distribution, day 2, no, day 1.
Okay.
Day 1. Wait, give me 1 minute.
Okay.
So I've shared with you in my folder. You can check in the chat that my lab 1 is there. I'm also going to share the rest. So you can take it and just put it in the folder where you are. It's not a problem.
I will download it and then, okay, let me.
So I've put all of them in so you can download and put there, then follow us. So let's now come back. Yeah. So when you open, when you finish, Prof, the rest, because you are already there. So in my folder, in my lab 2, you can see I've got library SPDF and the library spatial reg. Can you run it from your side? Run this because you are calling SPDF in R, because we are going to use functions from SPDF. SPDF is one of the functions for spatial econometrics. So you will get used to it.
Yeah, sorry, I'm still saving. I'm still saving it.
Are you downloading?
Yeah, yeah, I'm downloading, and I probably need to. I think I need to enter. Probably I need to come up with. Okay, I will do this new practical 2 so that I don't overwrite what is there.
Okay.
I'll say 2.
Okay. Are you asking also download the packages?
Run it from your side. I want to see what will happen, because yes, you can run while Prof is downloading. You can just click on run this, the first one, SPDF. So you highlight.
In library.
Yes. You say library, SPDF, you run it.
Yeah.
What does it come? It should give you an error. Does it give you an error?
That I should run library SPDF. Mine doesn't give an error. A very recent error that I installed yesterday.
It was
the moment you open a script, if it notices that there is a library, it immediately asks you to install the package, because it will notice that.
Okay, thank you very much.
So
yeah, normally,
installed automatically.
Okay, yes, it normally asks you, when you open a script, it says, if it notices that the script, you don't have these packages, it asks you to, yes, thank you very much for that. It normally does that.
Okay.
So, but
should I now close the other things that were open? Should I close it so that I can open the new one that you send me?
You know where you've put it. You know the folder where you've put it.
Yes.
So if you know the folder, just go to session and go to set my working directory and choose that folder again. where
Okay,
you've saved
okay.
the new one.
Okay, let me see. Let me see.
While Prof is doing that, I want to ask the rest of the class. Jean-Luc, I want to ask Veto, are you okay? Can you see the script? Because you are too quiet today. Jean-Luc, can you see the script?
Yes, you
Wow.
can.
Okay, thank you very much. So now what you do, you need to call the library for these two, for the SPDEP and the spatial reg. So you can just highlight them and run. Prof Eta, are you okay now?
Yeah, now I can see when I click open, I see my lab 1, my lab 2. Yeah, my lab.
Select your lab 2.
Okay.
Yeah.
Good. Okay.
Open the script for my lab 2 because we want to start together now, because now it's spatial econometrics that we are going to do. So we are going to do spatial metrics. That's what we want to create now.
Okay. Okay. Let me just see where you are. Okay, let me see.
We are not far. We are just where it says the two libraries. We need to call the two packages, SPDEP and spatial reg.
Oh, yes.
So you highlight this. You can highlight this, then you run them.
Okay. Let me do that.
Error.
Okay. SPDEP and spatial reg.
It is giving me an error.
It means that they are not installed. You need to install them. So what you need to do, you need to install them. So you need to click install packages, like I'm doing in my console. You can copy that. You can do that. Install SPDEP, and yeah, you also install the rest.
Okay, install.
Even the rest.
Okay. Okay.
SPDEP, it will install. Then while you are installing, we'll come back to it. Let me continue for others. I will come back to it. For the rest of us, because we do have SPDEP and spatial reg, now we can start working. Remember, we've saved the data called my data one RDS in the previous operation or in the previous session. You don't have to worry because I've saved it also in practical too. It's there, so you don't have to worry. So now we are telling R to go and read that data, but this time around, when it read it, it assign it to my data one. So this is the function. So it says, go and read on my folder this object and give it the name my data one. So you just highlight that and you click, you will see that it will read what we've created in the past session, my data one. So you can highlight that and read it and run it, sorry. And you should have now in the data, in the environment panel, you should have my data. And once you have my data, it means that it's there. So you can check the class. We check the class, it says it's a spatial polygon data frame, so which is okay, that's what we created. You can check the names of the data component part, they are there as we've done it previously. And remember, I told you, you can also plot any spatial polygon like we've done. So like in this case, forget about Windows, we are not going to use it because I want you to see what is happening in this panel. So you just highlight plot. When you highlight plot, you see that this time around, I'm saying the borders should be light blue. So I can put gray, I can put blue, you see? So I'm plotting now. You highlight, then you run. When you run, it takes a little bit, some second or minute. Yeah. and it's giving me, there is no comments. I don't know what happened here, but it's okay. This is just a warning sign. Don't worry. But at least it has created a plot. So you can plot them. But this is a very ugly plot. We will see how to do the plots with another package as we progress. This is another, the map is not good. So now this exercise that we want to do is very important. Now we are touching to spatial econometrics. The first one, we want to create the spatial weight matrices, the one that we've talked yesterday. And we're gonna use contiguity. Why are we using contiguity? Because these are polygons. These are things that are touching each other, so we can use contiguity. It's easy. So I've put there the comment. This comment is for you to go and read. So you read it later, but they are very important because it will also assist you. So the first step that you need to do when you are creating a spatial matrix from this spatial polygons data frame, you need to create the list of neighbors. You remember when we gave the formula for spatial weight matrix, we say n, there was ni, so the list of neighbors. So there is a function which comes from SPDEP called polygon to neighbors. This is the function, but they've put it in abbreviation. They say from polygon to NB. NB means neighbors. That's what it means. So from this polygon, this is a polygon, by the way. So from the polygons, creates neighbors. So you just put this function. Remember the criteria that we said, because it's in contiguity, we said it could be queen or it could be rook. So you can say queen. When you say true, it means that it will create the list of neighbors based on the queen. Remember, the queen is the edges and the side, whereas the rook is only the side. That's what we say. So once it creates that, it's gonna put it in NB1. So NB1 is just an object. You can change the name here, you can put whatever you want. So I'm going to create it. So I'm going to highlight this and create this. It takes a little bit second or minutes, but because it's a lot, because it has to go for all the polygons and do the exercise. So it's done now. So I've got a list of the neighbors for these municipalities. If you want to see them or you want to see what has happened, you just click also neighbors, neighbor NB1. When you click, it tells you what is neighbor NB1. It says it's a neighbor list object. Number of regions. So regions, in this case, it's spatial unit, which are municipalities, says 232. Number of non-zero links. So number of neighbors, that's what it means. It means 1230, that it is. The percentage of non-zero weights, it's 2. So it gives this information. It's very important. You can also check the structure like we've done. I told you that for each object in R, you can check the structure. So the structure is there. It says it's a list. I told you that the list of neighbors. So it says it's a list, and it gives you now the first element is 1 and 3. So it says for the first element, which is the first municipality that is ordered in this data, the first municipality has got 3 neighbors. Neighbor 4, neighbor 30, and neighbor 74. So if it was by names, it was going to tell you by names. So like municipalities, which is sitting at level 2 or row number 2, has got 7 neighbors. Neighbors, which is sitting at 3, neighbor that is sitting at 4, neighbor that is sitting at 37, 77, 82, and so forth and so on. So that's how it is. You can see, for instance, this one has got many neighbors. So like this has got 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one has got 9 neighbors. Others have got 3, others less than that. So that's what it is. So what we've done, we've just created the list of neighbors. And this list, we've used the Queen criteria in the contiguity. You can also use the Rook criteria. So here, when we're talking about Queen, we said true. But here we are saying false. It's because we want to use Rook criteria. Then we can click there. You'll observe we've created. It's still creating. It will take time. It will take time, little bit time, but yeah, now it is done. So you can also see NB2 like we've done with NB1. Oh, sorry, I made a mistake. Excuse me. Yeah. So you can see what is NB2. So I'm writing it here. NB2, you can also do the same. Then you just run it. It tells you. So let's observe now. I've done NB2 and NB1. Check properly in the console. For NB2, how many links that are non-zero? It means that they are neighbors. The links are 12, 18. Whereas for the Queen, the non-zero links are 12, 30. That's what I told you. Normally, the Queen criteria will give you the number of neighbors that is higher than the Rook. Because in the Queen, you are taking both sides and the edges. Whereas in Rook, you just look at the side. So that's what happens. That's why you see here 12, 18, whereas here 12, 30. So that's the difference. Now that we've got the list of neighbors, you can now create the spatial weight matrix. Remember, in the spatial weight matrix, we were now, because we know the neighbors, we were now allocating the weight to the neighbors. So that's what spatial matrix is. You are now allocating the weight to the neighbors, but in a format of a squared matrix. So that's what we'll do. There is a function called, there are many functions, but we'll start with this, the first one. The first one, you are saying that NB to met, it matrix. So NB, it means list of neighbors to matrix. So we are telling R to take the number of the list of neighbors and give the weights so that it can create a spatial matrix. That's why you see here in this, the first element that comes there is the list of the neighbors. And we also put style. Style means, you remember I told you, you can standardize your spatial weight matrix so that the lines, the rows, when you sum the rows, they are equal. Each row will be equal to 1. So you can standardize or you cannot. So that's what style does. Style tells you, do you want me to standardize? If you say B, B means binary. It will not standardize. It will be just 0 and 1, 0 and 1. But remember, I told you, for certain functions, when you are running certain functions to estimate a spatial econometric model, they require you that you should standardize the spatial weight matrix, because that's how, for the computational purpose, they are designed that way. So in this case, we are not standardizing. We are just saying, give me the binary. So when you click here, it means that it is going to give you a spatial weight matrix, the first one, which we're gonna call W_1. So we create it. You see it very quick. It's already created. You see, it's already created. So don't worry about these ones. I can run these ones. This one is just to, you are giving the number of areas, you know, to say dimension of W1 so that you get the number of sites, because dimension, remember, gives you the number of rows, because you say dimension 1, it means only rows. Then let's click on it. There was a purpose why I did this. So we say it's number of sites. You can even say number of sites if you want to see it. It should be 232. Number of sites, 232. So number of edges, you take the spatial weight matrix, you sum everything and you divide it by 2. So number of edges. Now we are asking if it's a symmetrical. Don't worry about this. You'll do it. I'm just doing it here. Don't worry about this one. Really, don't even run this. It's okay because we don't change anything. This was for me when I was doing my own thing. So now we want also to run the first one that we've created. We've used the list according to the queen. Now we are using the list of neighbors according to the rook. This is now the rook. Still binary, you can run it. So don't run the rest here. Don't worry about that. So now we do have 2 spatial weight matrices, W1, W_1 and W_2. The difference between the 2 is that one is using the rook, the other one is using the queen criteria. So we do have the spatial matrix. So if you want to see it, you can just come here and click on W1_1. No, it's a wrong one. Underscore, not minus.
Yeah.
You see, it gives you can't even read it. You see that it's very complicated. You can't read it. But here we've transformed this one from a list to a matrix. Please, this is very important because we are going to use a second one, which we're gonna say from list to the LW to another format, not matrix. So there is a difference because the difference comes from the fact that certain functions can accept a spatial weight matrix which comes in this format as a matrix. Others, they will accept it as a list matrix. So which is the different? So we've done, before we go the other routes, we've done this exercise, the coordinates. You know how to do it. So you can do the coordinates and you can plot. Here I just wanted to show you in terms of plotting. You can plot in another way with coordinates. So you know how to do the coordinates. Let's plot. Don't worry about the windows. Don't use it yet. You can just plot my data as it is. It is plotting now. You see, don't worry about the warning message. It's the first time that I see it. It means that there is something that I need to check, but it's okay. You see the plot, I've plotted this, and we've done this even in the previous demonstration. So I plot this. So now that I've got my coordinate, you remember the coordinates? Coordinates are the centroid points. So the centers, the point for the center of each polygon. So now I've created my plot. I want to link now this plot and to superimpose these links for the centers so that we see that really they are from the centers. So once we have the plot, you want to modify your plots. You want to add things on your plots. So you do this, you run this function. This function is different from this. You see, the first element now is the list of the neighbors. So I will put the list of the neighbors. I will put the coordinates, which are the point of the centers. You see what will happen. And this is just to say the color, to add. Add means that I'm superimposing this one to the first one. That's what add means. So I'm not creating a new one. I'm just superimposing. That's what add means. If I say force, it means that it's going to destroy this, then create a new one. But the idea is to add on, to superimpose on this. So let me run it and see what will happen. Check what will happen. I think it's still doing. Wow. Why is it? Yeah, now it's done. Can you see what it has done? So it has superimposed the links. So you see, for instance, this where I'm pointing, there is a point there. That's the center for this municipality. So now it links the neighbors of this municipality. So this municipality, according to the Queen criteria, is neighbors to this one and to this one. So it links the centers. So we can do this exercise. So as we can see, very simple to do it. Can you all see it?
Yeah.
Hello? Okay, thank you very much. So you can see the importance of coordinates and the list, how you can play with things. So this is how we can do it. So on the map already you can show, although it's very difficult, the links are many. Remember they are 1,218. Oh, no, 1,230 for the Queen. For the Rook, it was 1,218. So there are many links. So now let's forget about that one. Let's come back to spatial weight matrix. We've created spatial matrices in the format of a matrix with the function NB to met. So for SPDEP function in the SPDEP, they normally require the spatial matrix to be an object of list W. So that's what list W is there. Or let me just do this. Let me say, what is the class of W_1? W_1, it tells you that W_1 is a matrix array. So it's a list, like it's a list with the NB. So now here we want to create the spatial weight matrix, but in a different format. Format in the sense of R or the functions, but they are the same. It's still a matrix. So here we are going to use a function in the SPDEP file, which is NB to list W. That one was NB to list to met. This one is NB to list W. So it's a function. So the same structure, except for the name of the functions that are different, but the structure is the same. But list now follow here the style. We say W. W is a standardized. The rest, the B is non-standardized. There is standardized, there is non-standardized, there is also another format which is U and L, but I normally use the standardized. Most of the people, they use standardized. So let's run this matrix. And because we are using NB1, it is according to the Queen criteria. So let's do it. It is already done. So you can see it. You see now the difference between a matrix that is constructed with NB to list W and NB to met. When you say NB to met, it's a matrix. When you click it so that you can see what is happening, it just gives you the matrix and you can't even read. But for a spatial matrix that has been created with NB to list W, it gives you the summary. When you click on, say, W1, it gives you the summary of the information that you have in that matrix. First one, it says characteristics of the list of objects, number of list objective, number of region 232, non-zero links, the same like the list 1230. It gives you, then it tells you the style of the weights. It's W, which means that standardized. And it gives you even the weights, N, meaning that how many observations, 232. Constants, NN, summary. So it gives you all these informations out, okay? Sometimes you don't even look at it, but it gives you whatever you want to see for that matrix. So let's create the second one. The second one, the difference is that here we are using NB2, which is the rook, not the queen. So you just highlight it and you click. You can also see it. So you can also, if you want to see the structure, you can see the structure, give you the structure. And if you want to see the class, let's say class of N1, W1, it says W1 is a list WND, whereas W_1 is a matrix. As we can see, it's a matrix. So they are different in terms of the classes. So we've done the spatial matrix. We've created a spatial weight matrix. So that's how it is done. So the packages are SPDEP and spatial reg. There are also other functions, but these are the mostly used ones. So we've done that. So we've done that with the data which was already in the folder that we have. So now the second thing that we want to do, it will combine. I wonder if we're gonna finish it in 8 minutes, but let's do our effort. It will combine two things. One, you can also download the data, as I told you, which are in some packages, because there are some packages that come with the data. Like I wanted to tell you the other time, like in Stata, you have system use and so forth and so on. So in R also, there are some packages that have got data, and you can just download the data using those packages. Like here, there is a package called SP data. So this SP data, it's mostly containing all the data for demonstrations, the spatial data, by the way. So there is a data called Columbus. So that's why I said, don't do the exercise of Columbus, because we're gonna do it now. I forgot to put this. So now we're gonna collect it and we will come back, we'll go back to that exercise. So this line here, you remember this function read OGR is for you to read the data from the file that are in shape files, you see? So now we are asking R to read in the system the shape file called shape Columbus, and the package should be this package. Because there are many, we tell R read take just the first one. So that's what this one means. It means that one. So don't worry, you'll learn about this later, but we are reading, you need to have this package. If you don't have this package, like, if you have the package, you've already installed the package, you don't need to say library in this way. Because by putting this function this way, R understand that you first need to go and collect the package and take the data. So you don't have to call the package again with library. So I'm going to click this and you will see what will happen. You see it now collecting, and you can do the same from your side and see what happens. Because for me, I've already called the data and I've named that data map. So it's map already. So you can structure also this map, what it is, it gives you the structure because it has got different levels. You can now, what I want from this is just the data. So because this is, let's say, what is the class of map? Let's see the class of map. Class of map, it will be spatial polygon. It's spatial polygons, DataFrame. But what I'm interested in the data component for now. So I can also select just this component part. So now what I'm doing, I'm saying, take map, but give me the spatial data and allocate it to a new object. So this is what it is. So data, that. So that will be the data component of map, which is data for Columbus. So you can see the structure now. When we check the structure, you see it says DataFrame. So it's DataFrame. It's because I've eliminated I've deselected the polygons part. So you can also do that. And you can plot this. Let's plot it. If we plot it, what will happen? You see, it has given me the data for Columbus in the US. So these are counties in the, so that's what it is. And this is the data that I wanted you to work on. So you can now create also the same queen, because in Columbus, you remember this is a polygon. Because it's a polygon, you can create the list. So we can also create the list like we've done. Queen is true. R. This is an abbreviation for in R. When you see, when they say true, you can say T. R understand that you mean by true. So that's why I put here T only without putting the full word in terms of true. So let's create this for Columbus. So I'm creating now the neighbors for Columbus. So let me see what is in the list of the neighbors. It tells me that the list, this is a 49, regions are 49, and the neighbors, the links are 236, and so forth and so on. So I can create a spatial weight matrix with this and forget about this one. I can also create the coordinates like we've done. So let me now create, let me remove this. Let me now create the links like we've done previously. You can see the links are now there. This one, because it's small, at least now you can see the links clearly now. You can see the centers, what I was saying, centroid. These are centroid. Now they are showing you the links. So easy to do in terms of plotting. If you have to put it in a paper and so forth and so on. So let's create now a matrix, but with list W for this and B. We create one, and let's see the structure. And this is the structure, it's a long one. So if you want to drop some element in the links, you can also do the same, and so forth and so on. So this one, I'm not going to dwell much on it. You can do it on your own, but let's do it and let's plot and see what will happen. And let's create the windows. So now we are creating a plot. We've dropped something, and it's creating, it will create two maps normally. Taking long, but let's see what will happen before we take our lunch break and come at 2 and see whether we can finish. Yeah, it's taking long. Okay, let's forget about it. It's taking long, but it normally should give you two plots. So what we've done here, we've created the spatial matrix based on the contiguity. When we come back, or give me 1 minute, give me 2 minutes. I need to finish this so that when we come back, let me see what we can cover. Yeah, let's just go on break. We'll see what we can do. Okay, so I'm done. We can go for the break, and I'll manage to finish when we come back. We'll see if we can finish. Is that okay, or is there any question maybe before we go?
Okay, so this one was based on
contiguity.
Okay, and the data is Columbus, ne?
Columbus, yes.
Okay, but these are the data that you say you mistakenly did not include.
I didn't include, yeah, because I wanted to give you an exercise previously to say, can you, yes. So I forgot to include this data, yes.
Okay.
Yeah.
Okay.
Okay, let's go for the break, and we'll resume at 2. Or maybe, is it not too far, because we need to finish. Can I say in 45 minutes? I'm stealing your time, sorry. Can we come back at 45? Oh, it's quiet. People are gone now.
Okay. I think they want to. I think they want to come back at 2.
Okay, let's say 2. Okay,
Doc?
thank you. That's 2.
Doc?
But I'm here. If you yes, sir.
Yes. You said we finish it at 5, right?
Yes, I was asking that we can finish at 5, because you see, this is just practical 2, and we've got 5 of them. Can you imagine?
Yes.
Yeah, I don't know.
Okay, no, but I don't have a problem.
Yeah.
On my side.
Okay, no problem, sir. Okay, thanks a lot. See you at 2.
Clement.
Isaiah, how are you, sir?
I'm fine, sir. I'm enjoying this session.
Oh, thank you very much.
Yeah,
Thank
I
you
wanted
very
to
much.
ask something.
Yeah.
When you draw the map in
Yeah.
R, can you add
Yeah.
this some other components like the scale, like the north arrow?
Yes. Yes.
Oh, okay.
Yes.
No, that's
But
quite
yeah, you can do that. I don't know if we'll be able to see it. Maybe we can, maybe yourself and mine, we can have a discussion on a separately.
Okay.
I normally use, there is another software that I normally use when I want to create my map, because I like that software. So I will just create an object and send it to that software. It's a QGIS. I don't know if you've heard about it. QGIS.
Yeah, I know.
It's also, yeah. So I normally put it, because QGIS, for me, it gives me nice maps. So I do that in QGIS, and that's why I put the legend, I put all those things. I do that in QGIS. So maybe we can have a session where we can discuss, and I can show you how I do mine, then we can see it. Yeah.
Okay, no, thanks. My pleasure.
Okay.
Okay.
Sure.
So is the software, is it available for free, or you just take your data and then you take it to the internet and plot it directly?
The QGIS?
Yes.
No, it's an open source also.
Yeah, it's a
in fact, it is South African software. It was developed in Stellenbosch.
Okay.
Yeah, it's free of charge. It's an open source like R.
Oh, that's good. That's good.
Okay.
That's good. All right.
Sure. Okay, let's meet at 2.
Yeah, you talked about the source for getting the Arugundade also posted.
Yes. Okay. Let me check it now as you remind me. I'll post it. I'm checking it now. Yes. I've got it already.
The source for the QGIS.
Yeah, let me see. Let me post first this one.
Okay.
In the chat. When others come, they will see it.
Yeah.
So this one gives you for any country, it's free of charge for any country and for any level, whether you are, if that country has got provinces, it will also give per province. If it has got municipalities, it has got also municipalities. So the one that I've sent to you. So QGIS, let me also check for QGIS. GIS.
So you said the link that you've sent, which is gis.org.
Yes, Prof.
That one.
That link.
Sorry, I can't get.
Yes,
you.
Prof. You can. I'm listening.
No, I'm
we
saying
can talk.
that. I'm saying, does the first, you said the first link can go to province for each country?
Yes, it depends in the administrative kind of divisions that you have in a country. So if
it can go to the lowest administration of each country.
Yes. Yes.
And are you able to link this to? Is there a package that takes it to R?
Yeah, you can do it. What normally I do, okay, they should be, but I've never done that. What I normally do, I just download the shapefile, then I put it on my folder that I want to work, then I call it. So you can just download the shapefile. You see the file that we've said, the three extensions, which is S. Yes. So when you are downloading, make sure that you have those 3 at least, but they will give you more than that. I normally take everything. So I take everything, then I put on my folder, then I start working with that. So I don't go with R.
We go to any of these websites, we find the shapefiles there.
Yes, the first one. The second one is for GIS. So the second one is for I was talking to Isaiah that there is another software which I normally use for creating my maps so that they appear like people want them to be. Like you put the legend, you put the arrows and all those kind of things. R can also do that, but I've never mastered that skill for me. I prefer to do it in QGIS, because QGIS, it's just clicking the button and you are just putting things. So I prefer using QGIS. So that second website is for the QGIS that I was talking to. So I shared it with one of the participants who wanted to have the, because it's an open source.
Okay, thanks.
Okay, pleasure. Connect, but it will be unfortunate for them to leave this time because we haven't yet done any functions with regard to spatial econometric model. So it could have been better if maybe they left where we have done a model. That would be good. So looking at the time and the material that we have in terms of so that we can cover, we still have a lot. So what I would suggest is that because you have the presentation that I've sent to you, I am not going to really talk to the presentation. So I'll make sure that I will do all the practical. So because there will be two practicals, practical 4 and 5, that are related to the presentation that I've sent today. So while we are doing the practical, that's where I will be explaining also the things, because yeah, the practical are very detailed. So I'll be also explaining the model, because now you understand why we are not using OLS. So at least that's the most important part. So what remains in the today's slide is just to show you we can use GMM and so forth and so on. Then the rest topic, the last topic is talking about how to test your model. When you estimate now a model, how do you test to know that there is spatial, you know, or there isn't. So we can do that in the practical also. So that's the approach that I've taken, so that the 3 hours that we have now, we can be able to cover everything. Then on your own, you can read the slide. But if there is any question, maybe I'm available. You can send me an email. We can discuss if you seem to not understand some of the things. So that's the approach. But at least it has taught me now to say 2 days is not enough. So we need to, if we have to organize again a session like this, we need to put at least 3 days. 2 days is not enough. Okay, and plus we are also doing it, you know, virtually. Maybe that's what complicates also the matter. If it was maybe face to face, it was going to be very easy. So I've posted on our chat some of the links or the website where you can be able to download the shape files. So the first one is you can download the shape file for countries, any country. So it's free of charge. You can download. It can also give you particularly they give you the information in terms of the administrative subdivisions that we have in the country. So you can download that. The second one is just for there is this software that I normally use to do the maps. Although R can do that, and it can even do better, but I prefer that one because it's easy in terms of just clicks and so forth and so on. So I normally, when I do my analysis in R, but when I want to present maps, which I want to put in the paper or in the presentation, I prefer to use that software. It's also an open source, QGIS, so you can download it. And the rest are also where you can get the information for South Africa in terms of the shape files, so municipalities, whether you want at the province or whatever. But there is one site which is very important, which I said you need to pay. But I looked at it, it has got a lot of information, even the location for banks. Location. So that one, I think it's very powerful. Unfortunately, you need to pay. But yeah, that's the price that we need to pay for this. So I will also investigate. I've never used it, but I will also investigate. I've just found it and I said, maybe let me share it with you. So you need to investigate and look whether it's interesting based on the work that you want to do. So those are the few slides that the few websites that we can check for South Africa. I'm saying even for Africa or any other country, because the first one, it's any other country. But if you want to work we're using the US data, there you don't have to worry. They've got a lot of data. They've got almost everything. They've got almost everything, so you don't have to worry. Okay. So we'll resume, and we are going to continue where we left, from where we left.
Yeah. I'm just a small comment. I'm just
Yes,
wondering.
Prof.
Yeah, I'm just wondering why sometimes it's just too difficult to get the data. You know, I understand. You know, if there are data that deals with state security, for example, those ones we understand. But some of the data, you could see that there is no danger to the stability of the government, the security of the state to not be impacted. But I don't know. I don't know which other reason could be why sometimes it's to get the data.
Yeah.
You even have to pay for the data. Some of the data that can be made. Readily
free
available.
of charge.
Yes.
Yeah, it's I think they are not just creative. The reason that they are giving, like Start SA, they say it's confidentiality because this data belongs to companies. So maybe you can take the data and you go and sell it to the competitors of these companies, so they will know what is happening because they do information. That one I agree. But what we proposed them to do was like what DHS is doing. What DHS, what they do, they collect data from the household, and they do have also the information in terms of the enumerated areas. So they have a process before they publish the data, or they give you the data related to the location. They displace the data. So they are not going to give you the actual longitude and latitude, but they're going to give you something that is close to. So they've got a method where they displace all the data in terms of longitude and latitude. They displace them, maybe using 5 kilometers or 10 kilometers, something like that, so that even if you want to follow up the household, you will not be able to follow because it's at 5 kilometers at least. But that data, you can still use it because they do a random displacement. So it's like they are reshuffling things, but you can still use it for spatial econometrics because it's like they've just displaced things, but in terms of the distances between municipalities or between clusters, they're still the same. They didn't change, just displacing in terms of when you want to plug it so that you can follow up the household, you will not be able to do that. So that's what DHS does, and you can use that data. So what I'm saying is that it's a matter of Start SA not being creative. So they should just create a way of avoiding people to, play around with the data so that they can follow these companies. So they can do that. And I remember there is a new data set that Treasury has done also, Treasury and Start SA, where they collect data from the tax data, administrative tax. They create a set of data and they anonymize the companies. So you don't know the name of the companies, and people are using that data also. So in terms of space, they can also create something. It's just that maybe they haven't yet seen any interest to do that. But if we can push them, maybe they will find an interest and they will do that.
Okay. So this will add to a discussion that we are planning to have after this workshop.
Yes.
Thank you. Thank you.
Yes, Prof. Okay. Thank you very much. We are going to start from where I said. And as I said, let's just focus on the practicals because practicals, I've done them in the way that they are very detailed. So even the things that I'm not going to cover, which are in the presentations, you can follow them after, but you can do through the practicals. One will be able to follow that. So I'm going to share my screen and yeah. So we've created a spatial weight matrix using the contiguity. We want to create now, remember we said we can use also distance. And distance, we said it can be neighbors, nearest neighbors. So the distances that are the shortest. So we can say, okay, this one is the shortest, we can take it as a neighbor, that one not, and so forth and so on. So we are going to use based on the distance. So in SPDEP, you do have a function called K near, you see there the one that I'm highlighting. K near, so nearest neighbor. So that's what it means. So you can also use this function to create that. So if you want to see what it means, you can just run this. It will give you the L, then we can see. So the first thing for you to be able to use the nearest neighbors, you need first of all to create the longitude of the centers. Remember, the neighbors are taken according to the centers. You remember the example that I was showing you in metrics to say the nearest, it's at the center. You take the distance from the center, not at the edge, not somewhere else, but at the center, and the distance from the distance up to the center of the next polygon, and so forth and so on. So for you to be able to know the center, you need to have the coordinates of the centers. And as I told you, the function coordinates, this function gives you the coordinates of the centers, so the centroid coordinate. So we've already run this, but we can run it again, because here, what it does, it has given us the coordinates of the centers of that object called my data one, which are municipalities. So now that we have these centers, the coordinate of these centers, so now we can calculate the distance between the centers and look at the shortest so that we can estimate. So that's the work that k-nearest is doing. So it will do that job for you. You don't have to worry and so forth and so on. This is just in terms of because distance is calculated in different formats. It can be Euclidean or whatever. So this one is also, yeah, we can put it force. It's just in terms of which measure of distance that you want to use. So you can, if you want to know more, just click on k-nearest. It will tell you what long let means. So that, but normally it considers as the surface is flat. So that's why we put through there. But there are different measures that one can use. So for the purpose of this exercise, we are not going to go into details, but when you click on the L, it will tell you the syntax and you'll see. So now what we are doing, when the syntax is you need to put the coordinate. You see the importance of having the coordinate. You need to put the coordinate, but you need also to put the criteria to say, because when you say nearest neighbor, how many of them? There can be plenty of them. So how many of them? So if you say just one, so when we say k is equal to 1, k is the number of nearest neighbor. So when you say k is equal to 1, so it will choose just one neighbor. So each municipality or each spatial unit will have just one neighbor, which is the nearest amongst others. So that's what it does. You can go to 2, you can go to, so you can go up to 10, depending on your research question, what you want to achieve, you see. So we can run these functions as they are, can just highlight them and run them. They will go very quick, they are there. So what you've done with that, you've just created the nearest neighbor. So now you need to put them in a list form, because the way they are now, they are not in a list form. So if you want to put them in a list form, you need to use, you will use now this. So KNN to NB. It means that these, we are taking these ones, you put them down on the list, like we've done with the NB, you see? So you, like for instance here, I'm saying just for neighbor 1. So I'm creating now the distances that I've obtained into a list of neighbors. Here I was obtaining the distances. This one is just to obtain the distances. But here now I'm putting it in a list of neighbors. So I put that like this one, list of neighbors. So let's check it like we've checked with NB1. You remember NB1? So I can highlight this. Then it tells me, it gives me the same information like it was giving me for NB. But now you can see here it says number of non-zero links. They are 232. Why 232? It's because at least there is one. So because they are 232, so the 1, 1, 1, 1, so it will be also 232. So if it was 2, let's check for 2. Let's check for 2. Let's do for 2. We run this and let's check. You see that for 2, it has doubled. 464. Let's check for 3. It will also triple. And let's see. You see now it has tripled. So that's the logic. Now we can see that this is, we've created the neighbors based on the nearest distances, but the criteria could be 1 neighbor, 2 neighbors, 3 neighbors, and so forth and so on. So what you have in this K, for instance, K5NB, it's the list. So now you need to create a spatial matrix now, like we've done previously. We had NB1, NB2, so we had to create the spatial matrix. Spatial matrix is giving now weights to these neighbors that we've created, and in a format of a matrix, which we're gonna use when we are modeling when we are estimating our model or when we are calculating the spatial dependence. So the same applies. You remember there we said it's NB2 list W. So we do the same. It's the same function. We've used this function. But here, instead of using NB1, we use the list that we've created based on the distance and based on distance and nearest neighbors. So like this one is for the one neighbor, 2 neighbors, nearest neighbors, 3, 4, 5, 6. So I can create the spatial matrix. Just highlight them. So they are there. They are created already. So what is important to remember is that you need to extract the coordinates of the centers. So once you extract the coordinate of the centers, because that's what you need, so that you can calculate, the distance is calculated between the centers, not between the edges or somewhere else. It's between the centers. So once you have the coordinates of the centers, you are able now to calculate the distance. And K near neighbor gives you, does that work for you. It calculates the distances. So that's why in the syntax, in terms of the input, you have to put the coordinates, you have to put the condition to say how many neighbors, nearest neighbors you're going to calculate, and which distance measure that you want to use. So you put those in the function, then it will be executed. It will give you what you want. So that's what we've done so far. So that's the difference between contiguity and distance, but distance in terms of nearest neighbor criteria. So we've created this. So if we want to see this matrix, for instance, like this one, it's a spatial matrix. So you can just say, give me K, tell me what is KW. You see, it tells you like it was telling you when we were saying W1. So it gives you all the information and it even here, you see how it does everything. So there is one thing that I would like now to insist, it here. You see zero policy comes here. We didn't put the style because we are, normally the style doesn't matter here. It will just give the neighbors 1 and 0. And you don't have to standardize it because this matrix is not symmetrical, because these are just the neighbors, nearest neighbors. For the contiguity, the spatial matrix was symmetrical. That's what we said even yesterday. So, but zero policy, we could have done it even in the previous one. Zero policy is also a criteria that we put. It means that if there are, let's say, it mainly applies to the contiguity. If they're island and you don't want it to return an error to say there is an island which is alone, which is not connected to any other municipality. So you say zero policy is equal to true. True means that you're gonna exclude those islands. Like in the case that we've seen in Great Britain with Northern Ireland, which is an island. So if you want to calculate the spatial, to construct a spatial matrix for Great Britain, you're gonna put this, you need to put this criteria so that when it's true, when it sees that it's true, it's going to remove Northern Ireland in the analysis. But remember now, when you do that, it means that your spatial matrix will have few or less than one object, whereas the data itself has got, let's say 232, but this one will have 231. So when you do that, you need to be cautious so that either you go also in the data, you eliminate that row so that to do the analysis. Otherwise, it will give you errors. And if you don't know where you made a mistake, it will be very difficult for you. So it could be because of that. But since we are working with South Africa, most of the time, we don't have problem because we don't have island, and so you will never encounter this problem in the case of South Africa. But if you are working with Africa, for instance, where you include, let's say, Mauritius, you include Seychelles, you will have this problem if you use contiguity. So you can also plot this, what we've created now. So let's forget about windows. Let me clear the plots. Yes, now it's clear. So you see this function which says par and bracket mf row. So this is just to say, I want, if you have got many plots that you want to show at the same time in this plots panel. So you want all of them to be shown there at the same time. So you need to do this. So you are dividing, you are saying that I'm dividing my panel. This is the number of rows. So it will divide the panel in one row, but in three columns. So because I need 3 plots, that's why I'm doing this. So this is a function, you need to know it. It's a way of plotting many figures, or showing many figures in one page or in one panel. So let me run it. I run it. You won't see anything because I haven't yet done any plots. So that's why it's a function. But when I start plotting now, because the function is already there, it will be doing that. So let me run the first plot. The first plot, we are saying, plot for me this spatial polygon data, which is called my data one. The border should be in gray. So let me run it. I run this function. You can see it's taking time, a few times. So it has run it. And I'm telling now R, add now. That's why you see in the second plot, there will be add. And you see you've got already one here. And you see it has created space. You see on the right-hand side of the plot, there is a big space, which means that it understands that it needs some space to put other plots. That's why it has put this one on the left. So I'm adding now. So I'm not creating a new plot. I'm adding a new plot on the first one because there is this a criteria to say add. So remember what we said, you can plot the polygons, then you add the list and the centroid so that you can show the connection. So that's what will happen. Let me show you. I'll run it. It has done. So you will see it will appear in very soon. It is doing the background work. So it will appear in the first, as we can see. You see now, there are black dots that have just appeared, meaning that I've superimposed the second one on the first one to show the links. As you can see, they are like these 2 municipalities that I'm showing. They've got only, this one is only neighbor to this one and this one neighbor to this one. That's all. It's because we are using distance, shortest distance. So if it was using contiguity, it was going to be neighbors with this one, even with this one. So you see, in terms of distance, and this is K number 1, so only one. Each one has got only one. So that's what it means. So this one, the neighbor is this one, and this one also. That's what it's showing us. So we can run the second one, the third one, up to, the third one. You will see what will happen. We will have 3 maps of the same kind of, with these links putting together. It's because we've told R that please divide the plot pen in 3 columns and 1 row. That's what it has done. You see, the second one is being created. It's taking time because it's creating the map. Maps normally they take long. So the third one, the second one is now done. So now they are doing the third one. So the colors are different according to what I've said. I've said gray, red, and green. So the last one will be green. So that's how you do it. Forget about the owning. It's a new thing that has just come. I think it's because of, I need to update my app, maybe. So it's still creating, it's not yet done, the green one. So that's how you put also. So we've now just seen how to create the spatial matrix based on the nearest distance. What is important, I repeat again, is to create, first of all, the centroid coordinates, because you need that, because the distances are based on the centers. Then you create you calculate first the distances, and you need to put the criteria. Distances, are you calculating it for one nearest neighbors, or for two? You put that. Then you convert that information by creating the list of neighbors. Then you go to the spatial weight matrix. Whereas when we were doing contiguity, we had only 2 steps. The first step was to create the neighbors, then allocate the weights in the spatial weight matrix. But here we've got 3. So you first create the centers, you create 4, we've got 4 centers, you calculate the distances, then you do the neighbors, and then you allocate. So we are done with the nearest. So let's say if you have to work with the cutoff distance, instead of the nearest, we say, let me calculate the nearest or the cutoff distance, 20 kilometers. So it depends on your choice. So what the function is, instead of K nearest neighbor, it is D nearest neighbor. So this is the function from the same package SPDEP. So if you want to know more, you just click on it. So here we are saying, let's cut off on 20. So you will also need coordinates, because the distance is calculated on the centers, so not on any other thing. So it's on the centers. So because we've already made the coordinates, that's why you see coordinate is there. So because we are giving a threshold, we are saying distance should be, take the distance from 0 up to 20. Normally it's 20 kilometers here, up to 20. So we've given the threshold. Anything that falls, let's say, which is greater than 20, it will not be considered as a neighbor. So I just run this function. Let me run it. I run this function. So what we've created is just the cutoff distance. And let's see what it is. So the difference between nearest neighbor and this is because this one gives us the NB, so the list of the neighbors, but it didn't give us, we didn't calculate, we didn't do the spatial weight matrix. So you can also do the spatial weight matrix just by the same, I didn't put it here, but you can, now that you have the list of neighbors, you can create the spatial weight matrix on your own. Let's create it. Let's call it spatial matrix 3. So it will be NB, because it's neighbors, to list W, and then we put this cutoff 20, because that's what we've just created, cutoff 20, and we say 0 policy, we say true. So we've created now the matrix, but in the script I didn't create because it will be repeating the what we've just said for the K nearest. The only difference is that in the K nearest, you calculate the distances, then you allocate the neighbors again. But here, you just, in one function, it calculates the distances, because the distances you've given, the cutoff is already there. So what it does, this function does already the work for you in terms of allocating the neighbors. Whereas in the K nearest, it just calculates first, then you need to allocate the neighbors, then go to the spatial weight matrix. Here you've got already the neighbors, so you can go to the nearest distance. So let me, because we've got, we can plot this again. So I can say plots, let me click here, let me say plots the neighbors according to the shortest distance. I want to show you this so that we can see what will happen. Let's see, it's still working in the background. There is no plot yet. You see, there is the plot. So this is just the polygon. That's what we've done. So now I want to say, show me the links. I need to put, like we've done with NB1, so the list, the coordinates, then I'm adding on it. I'm not creating the new, I'm adding on it. So let me click on it. Click on it. So it will add, it will superimpose on this one. So let's see what will happen. Let's see what will happen. So now I want to say, show me the links. I need to put, like we've done with NB1, so the list, the coordinates, then I'm adding on it. So let me click on it. Click on it. So it will add, it will superimpose on this one. So let's see what will happen. It's still doing the work in the background. You see what happens? It has added the neighbors. So you'll notice that by adding the neighbors, you will see that because we've said the kilometers is, let me make it big. I want to insist on this one because it's important. Because we've said there is only 20 kilometers, you can see that where there is black, a little bit dark, it means that these are the neighbors. The rest, they are not, it's just the centers, but they are not neighbors. It means that the distance from here to here, it's not 20 kilometers, it's more than 20 kilometers. That's why you don't see, yeah, now it appears clearly. You don't see this. It means that the threshold that we've put there is too short. So we will end up not having the neighbors, basically. So let's increase the distance and let's see what will happen. I've increased the distance to 100. So let me calculate for 100. So I'll run first that one, then I'll also plot it. So let me plot. Let me first decrease this one, eliminate this one. Let me plot. Now for 100, I'm plotting. You will see the difference between the two. It is there now. It is coming. Yeah, it's taking long because this is a plot. You see now, I've got, yes, sir.
I did try to calculate the weight matrix W3.
Yeah.
But it gives me error.
Okay, let me stop sharing. And can you share with us your screen?
Okay, let me get there. That is my screen. You can see this line 226.
Yeah, I see. You see, it says error. You know what it says error? The problem is it's not telling you where the error is, but I see the error. You see where you've put zero policy. You should put zero policy equals to true, to T. Change that one. Change this one. Say equals to 3.
Is it double equal?
Yes, no, not double, just as it is. So now run it. Let's see. You can run it now.
But you see, Clement,
now
you are able to see the error when you cannot see the error. This is with
no, it's because you are new. Okay. Okay. Thanks a lot.
All right, thank you. I think it has
Pleasure.
worked. Let me stop
Okay.
sharing.
Okay, sure. So what we've done, we've just created, first of all, the polygon. So now let us go and tell R to add the links. So we are adding now, we are superimposing. So I'm running this. Let me run it. So it has already done. So it will appear now very soon. And you will see the difference. You see the difference? You see now we've got the links. It's because where we have the links, the distance is within 100 kilometers. Because when we shorten the distance of 20 kilometers, we didn't have the links. Now we have the links. But we do have the links, but you can still see there are places, particularly in the Northern Cape. And the Prof. Eta can know this very well. Northern Cape is semi-desertic and it's very sparse. So settlements are far from each other, which is a reality. That's why the distances between municipalities there are very, very so long distances. That's why 100 kilometers in the Northern Cape cannot work. That's why you don't see the neighbors. But here, like in KwaZulu, sorry, Prof?
No, I was saying it's true. I am agreeing with you.
Okay, thank you. So in the Northern Cape, in the Eastern Cape, KwaZulu-Natal and Mpumalanga, you can see that it's they are squashed, if I can use that term. And in Gauteng, you can see where we are. It's there. So now let's increase now the distance again to 120. You will see that we'll pick some municipalities in the Northern Cape. So the threshold now is 0 to 120. Let's running. So we've run it. So let's plot it now. So we plot it. So the plot is coming. Yeah, the plot is there to be shown now. So that's why I was telling you I like distances, because it makes some sense. You know, when you are then contiguity, yes, contiguity, it makes also sense, but distances for me, they make sense in many cases when you are doing the spatial analysis, like the case that we've done now. Because if you take contiguity, you might find neighbors, but in terms of the influence, they don't influence each other because people are scattered. Of course, this is a municipality, but the centers are scattered. If you want to take the centers, that will be another problem. So let me show now the links for 120. So I've done that. Let's wait. You see now, we've picked up some municipalities in the Northern Cape, but few still, but at least we've picked. I've increased it to 150. They're still like this municipality here. Even if you go to 150, it will never have a neighbor because it's too far. I can't remember which one is this one now again. So this is how we do it. So we've done everything. So we can jump this, it's not a problem. Let's jump this, you can do it on your own. Yeah, even this one, I will jump it. You can do it on your own. So let's focus on this, what we've just done in terms of how to construct the spatial metrics, because the rest is just, you can construct it using sparse metrics, and so you can do it on your own. What I wanted you to understand is the logic of how to do, to construct the spatial metrics. So I don't know if there is any question, I can take them now. Then we go to the to the next practical where we're gonna now calculate, because now we know how to construct a matrix, the spatial matrix. We can now calculate the spatial dependence and estimate a model. So that's what we want to do now. I don't know if there is a question. Let me stop sharing.
Clement.
Yes, Prof. Yes.
I just want to ask if my map is always looking very small in the plot area. Is there a way that I can do to increase the size of the map?
Yes, you can go to zoom. That's the first example. Let me show you.
No, yeah, when I take to zoom, it opens a different window.
Oh, yeah, you can do this. You see my cursor where it is?
Shake it a bit.
I'm moving it. Yes.
Yes, I can see.
It's just, so you can click on the edge of the separator of the panel, so that you can, it will give you like something like a cross, so that's like we do in Excel. If you want to extend the size of a cell or whatever. So when you put that cursor on the separator, so it allows you to move across, so you can make this big. You see what I'm doing? I'm making small, or I'm making it big. You can also do that.
I am also do, but my problem is actually that my map is at a small dot at the center of the whole area.
Okay, I see where you are.
Space by the side.
Let me see. I see the error. I see the problem. Can you go to tools? Go up there. Click on tools. Then come down up to the last one, which says global options.
Global options, yeah.
Click on it. Then on the right, on the left hand side, 1, 2, 3, 4, where it says appearance.
Yes.
Click on it. Now look at the editor font size. Yours should be maybe 10 or 8. Mine is 14. Yours is how much is it?
Okay, I have put 9.
Okay, that's why the font is too small. So you can also increase the font. You see, mine is 14. So my font becomes a little bit larger. So that's why even the plots, even the things that I'm writing here, the font is big. So you can change that. You can put it 14, then you click on apply and OK. And let's see what will happen.
Okay.
So click apply and OK. Okay. So how is it now?
It rather increases the writings.
Only the fonts. Not the map. Okay.
Not the map.
Let me
it didn't
see.
affect the map. Yeah.
Okay. Okay. Let me
Okay,
think.
let's go
I'll
ahead
see.
then. I will find out afterward. Let's not take time. on
Okay. Sharp. Okay. Thanks a lot. So, oh, I made a mistake. Can you still see my screen?
Yes.
Okay. So what we've done, we now know how to do the spatial econometrics. So in the next step, we'll still do it, but now we are going to calculate the spatial dependence. So what we're gonna do, let's go to session, click on the session. When you click on the session, you go to set working directory. You are changing the directory now. And you say choose directory. Instead of practical 2, you're gonna choose day 1 practical 3.1. Practical 3.1. So I'm already there. I don't know if you are there also.
Practical 3.1.
3.1, yes.
Okay. Let me
you enter, so you are changing the folder like we were saying.
Yeah, I want to make sure that this time I do it the right way.
Yes, Prof.
So practical 3.1, and then I just click open.
Yes, you click open.
Okay.
Yeah. Okay. So other colleagues, are you there also?
I'm there.
Okay,
Yes,
thank you very much. So I can now close, or I can delete everything that is in my, so for space reason, so I'm going to the broom like we've done. So don't worry, because all the data that we're gonna use for that practical is in that folder. So don't worry, we can delete this. You will come back to it, it's not a problem. So you can delete it. There's nothing that you are going to lose. So let me delete it. I don't know what's going on. My machine now has stopped working. I don't know. I made a mistake somewhere. So let me stop sharing and check what is going on with my machine. Yeah, it has frozen. Okay, it's okay now.
Give it some, yeah, I was going to say, give it some minutes.
Yeah, no, now it's working. Yeah, now it's working. So I'm in that folder. As I told you, if you want to check in which folder you are, you just go to get working directory, bracket. Sorry, mine, I put 0 there. So it will show you where you are. You see, it says practical 3.1, the last one. So I'm there. So because I'm in practical 3.1, I want to use my lab 3.1R. So I will go to the open, like I told you, open that yellow thing. Can you see it? That yellow thing. I open. There are two scripts there. There is a script called MyLab 3.1 and MyLab 3.2 solution. So what I want is just MyLab 3.1. So I click on MyLab 3.1. I open it. So you should see it. It should be in this panel. There it is. So don't worry about this. As I told you, because you are in this folder already, you can put a hashtag. So this practical now is for us to calculate the spatial dependence. And there are some, I'm here.
Yeah, sorry,
Yes,
Clement.
Prof?
I think there is probably something that I am doing wrong, particularly when it comes to the saving of the document. Because now if I go try to open, I see my lab 2 R, my lab 1 R, then clear list. I think there is something that I'm not. Yeah, there's probably something.
Let's find a solution to it. Can you open your folder, not in just open your folder, not in R, the folder where there is practical 3.1.
Okay, let me just, yes, I opened it.
Yes, can you share us this? Can you share the screen with us? We want to see.
Okay, let me do this. Yeah. Can you see my screen?
Yeah, I can see your screen. Okay. You've got everything that is needed in the screen. So your folder is called, the main folder where the practical 3.1 is called day one copy, isn't it?
Yes.
Because that's what appears. So it means that when you are also going to in R, when you select the folder, don't select day one, but you need to select day one stroke copy. Are you doing that?
Yeah, day one copy, yes.
Yes, okay. So what I'm asking, can you stop sharing this? No, okay. Stop sharing it. It's okay.
Okay.
Now, show us share with us your R Studio.
Okay.
So that we can see.
Okay, let me now share. So it means that I should now start sharing it. Okay.
Yeah, start sharing.
Okay. Can you see it?
Now go to, yes, we can see it, but go to session.
Okay.
Click on it. Go to choose directory.
Yes.
Yeah.
You see what I'm, okay. And then
you are in the, yes, that's all. Click open.
Okay.
You don't have to, no. You don't have to, no. You've already chosen, so you are already there. Don't put anything in the folder. Don't put anything in the folder there. Remove this. What is highlighted?
Okay.
Remove what highlighted. Just cancel it.
Okay.
Cancel it. So you are already there. So you are normally there. So click to open. Open.
Yeah. You see what is happening.
Okay. No, you are clicking. That's why I see. You are clicking on the drop list. The drop list will give you what is already in the R's. Don't click on the drop list. Click there. Yes. That one. No, the big one, the yellow one. Yes. Now you see now. You have my lab 3.1. So now you can click, select it and click open.
Okay. Very good.
Yeah.
Very good.
Okay.
Very
sure. Yeah. Okay. Thanks.
Thank you.
So,
thank you.
You are welcome, sir.
Now I can stop sharing.
Yes.
Okay. Thank you very much.
Okay. You are welcome. So let's now start with this. You've got SPDEP. Then there is new, for those that when you, like Prof. Ngepa said that if you open a script and there is no R, what the R does, if there are some packages which are not, they are in the script, but they are not on the system, R will give you a message there on top to say, do you want to install this? So I think by now you must have received that message and you must have installed these packages. So there are 3 packages that we are going to use. We are going to use SPDEP, TeamMap, and SF. But SF, we've already downloaded it, SPDEP also. So if you don't have TeamMap, you need to download it. But I think by now it should be already installed. So what you need to do now, you just call them. So we consider this as a new session. Although we've already called SPDEP and SF in this session, but we are just considering it as this is a new day. You've closed that session that you're working on, so you need now to call it. Because we didn't close this, so it means that SPDEP is still here, but let's call it again back. Assuming that it's a new session. You just run, you see now it goes there faster. TeamMap is also, it's playing the role of ggplot2, but TeamMap, it's for the map, creating the, what we call choropleth map. Choropleth map, I will explain to you later. But the object that you are creating the map with should be of the class SF. You remember we're talking about class. We talked about data frame, spatial polygons. So that is very important in R because some functions, they only work with certain classes. So if it's in a different class, sometimes they don't work. So like team map is a package. So if you want to do some work in terms of creating maps, the class of the object that you are using, or you want R to create maps for you, should be of SF, not SF also is shapefile, but it's another class. The difference between classes, it's just the way things are stored or are structured. That's the main difference. You see, like in Polygon, you have polygons and you have data. Like in DataFrame, you only have DataFrame, but stored as a matrix. So that's the main difference. For now, it will be complicated to know, but what we need to know is that there are different classes, but as you work along, so you'll find it easily. So we've got this data. So now we are going to remember we talked about global spatial dependence and local spatial dependence. So we want to work with, we want first to calculate global spatial dependence. So there is a data set which is already in your folder practical 3.1. And that data set is called NHME.RDS. Remember what I said, RDS are data that you, for spatial, for R, so you can load them. I made also a mistake. I said you can only read them. You can also load them, like you load R data. So like this one, we are asking R to load this file, which is R file on our session. You see here, there is 0 in the environment. It is empty. It even written environment is empty. So when I load it, you just highlight it and you click run. You see now there is something that is appearing there. But it's appearing, although the file, we call it NHME, but when we load it, the name inside the file is not NHME, it's S, because the first thing that it gives you is the name of the file. So it's S. So that's why we're gonna use S instead of HMME. So we can say, give us the name of what is contained in the NH, which is S. Now it's S. That's why you see I've put the names S. So it will give me the names. It will give me, so there are 8 variables. So there is name, state name, population in 2010, average household size, average family size, income, household year, and the geometry. So let me also do this. You can also do from your side. You can write class S. So class brackets S to tell you which class is this data, so that we can see that it's not spatial polygon, but it is of class F, but it's a spatial data also, because we do have geometry there. So you can highlight it and you click there. You see it tells you it's a spatial, you see, it's a shape file. This is a shape file also. That's what SF means. And there is another component of data, like we are doing in spatial polygon data frame. So this is another class. So that's why we have to download team map, because team map works with this type of data, this type of class. Okay. So we want to see income, because when we put names there, it told us that income is already there. You see, income is somewhere there. Income is here. So now let's see what is in income. As I told you, you just put the name of the data sets or the object, then you put the $sign, then the name of the variable. So when we do it, it gives us what is contained there. So it should be in in thousand. 44,000, that's the first one. The last one is 42, because we do only have 26 26 observations. So And yeah, so that now let's calculate, we want to calculate the moran on this data. First of all, that's why I've prepared this script in details. First of all, moran only works for normally distributed data. I forgot to tell you that. If your data is, let's say, the variable that you are looking at is, let's say, a Poisson, it follows a Poisson distribution. Normally, you don't use moran. You need to use something else. There are some measures, but here we are assuming that we are working with normally distributed variables. So that's important to return. So how do you know that there are some checks that we can do to know that a variable is normally distributed? You can do it by histogram, for instance, like this one. We want to create an histogram of income, but income is in S. So that's why you put S $, income. So we highlight it, and let's see what you see in the plot. We have the shape, which is almost, we can agree that it follows, although there is a little bit skewness, but let's agree that it's well behaved at this stage. Let's close our eyes, agree that it's normally distributed. So now you can create what we call choropleth map. What does that mean? Because this data is a spatial data. So you can now visualize your data using, let's say, because we are just focusing on univariate, so income. So the values of income in each state, because we've got state now. So can we give, it could be quantile, or it could be average, or it could be standard deviation, so that you see, because remember what we said. We said spatial dependence means that values of an attribute of the same nature, which means that if they're high or low, they tend to be close by. So it means that we can represent that on the map. We can see on the map where really, if really there is a spatial dependence. Sometimes it's difficult visualizing, but sometimes it can give you a sense. So we use what we call team map package. So this is the function of creating the choropleth map of income. Choropleth, you only do it for one variable, it's univariate. Because if, let's say, income was your Y variable, and you are interested to know if there is spatial dependence, so that we can make a decision to say, must I use spatial data or must I? So you can do, this is like when you are doing your specification of your model. So you say, this is a function. So the function is tm_shape. You see the shape, it means that it's a shape file. It applies only to shape file. So this is a function. You put the function there. Then you tell R that I want you to team shape this object, and the object should be the data set. And that data set should be of class SF. Because S is of this class, I say team map this. So R will do that. Then I add other, I can stop here. It will still do the job. But I'm adding now informations. The second information is to team fill. So I'm saying you need to fill in terms of the colors, because I want to see differences in terms of the colors. And colors that you want to use, it should be based on one variable, which is income. That's why I say team fill, color is equal to quotation. I put income, so the name of the variable as it appears in S. Then I say which style. So style meaning that when they are filling the colors according to the income in each state, are they going to use standard deviation because they need to calculate the standard deviation? So they will have different values, or they need to calculate whatever they need to calculate. So they will calculate quantile. So they will divide this distribution in quantile. So now they are going to give colors according to the quantile. So the first quantile will be maybe, let's say, green, and the second one will have green, which is dark green, the third one, and so forth and so on. So that's what I'm telling R to do, say quantile, the style, and number of classes to say up to what level. I say 8. Then the palette is now to choose now in terms of the colors. So I'm telling R, go and choose among the greens. So there will be different greens that will be chosen. That's why you see greens in plural. Then I tell also R to put the legend. I think it's Isaiah asked me the question. So team map can also do that. You can put the legend. You can even put the arrow to show that you are in the north. This is the north, or you can put those things. But we'll stop here. But we said the legend should be outside the map. So let me clear the map, which I have here, so that when I'm clicking on this, you see what will happen. So let me highlight this and run it. You will see what will happen. It is running, nothing of error. You see now it has created the map. Can you see it on the bottom right? So there is a map which we call choropleth map for income. So it's showing you the income, the quantile, and the colors, they represent the classes or the quantiles. So like this one, this, which is not, I don't know, is it not deck, but it's, yeah, it means that the income start from, the class is from 37.1110 up to 39.95. And the dark one, it's up to 60. So these ones, they do have higher income, household income level, but you can see that where there is higher income level, so it's not only this one, it starts from here. They tend to be together because this is high, because this is this color. This color is from 50. So you see 50, 55, and 60, they tend to be together. So this map can already give you a sense that there is dependence for these ones, because those that are high, they tend to be close. Then those that are lower, they also tend to be close. But that point is always difficult to make also, because you might be wrong with visualization. But at least for this example, you can see the dependence that we're talking about, that similar values, when we say similar, we are not saying exactly. So it could be 9, 10, and 8, they are together. Then you see 3 and 2, you see. So similar values tend to be close by. And it has shown us that there is spatial dependence. So this is a way of, when we want to do an analysis, you check. But we still have to do the analytical parts. We need to calculate now, because we might be wrong in the visualization, particularly when you have a lot of observations. It can be misleading. So that's why the analytical is good. The statistic, we need to calculate the statistics. As you remember, we said for us to be able to calculate the statistics, we need what we need. We need the list of neighbors, so the spatial weight matrix, and the variable. And remember here we are calculating univariate spatial dependence. So we need first to calculate to determine the neighbors. Who are the neighbors in this data set? So we do the same. The function, remember the function in SPDEP, it will be, this is a polygon, because it's also, shapefile is also a polygon. So we can use polygon. So it says polygon to NB. So we are telling R to create the list of neighbors based on queen. Remember, queen is edges and side. So let me click on this. It has already created my neighbors for me. So let's see what is the NB. It tells me that NB is a list of neighbors. Non-zero links are 112, so they are a lot. The percentage of the weight is 16, and so forth and so. So I've created my neighbors. So if I want to see the first spatial unit which appears on the list of neighbors, I can just click NB1. So it will give me the first one. So I click. So the first one, I want to see who are the neighbors of the first spatial unit. So the first spatial unit has got 5 neighbors. It has got spatial unit 2, spatial unit 3, spatial unit 6, 7, and 20. They are neighbors to spatial unit 1. So now you can understand what we're meaning by the list. So it gives you the position of the spatial unit, then it gives you the list. This is now the list. What are the neighbors? So now let's assign weights. When we say assigning weight, it means that we are creating the spatial weight matrix. Because we know now the neighbors, we've got the list of the neighbors, so we can now give them the weight. And we do the same as we did. So we are going to call it LW. So it will be neighbors to list W. So we put neighbor there, and the style is standardized. Remember, when we say D, it's binary, W is standardized. And you see now we are putting 0 policy. If there is something that is here, let's say an island, although it isn't, but it's always good to put it because you don't know. So we just put there, and we've got our neighbor, spatial weight matrix. So let's see what is spatial weight matrix. We say LW. There it is. It gives us the same information. So let's say you want to see the weight now, the weight for the first spatial unit. Remember here we were saying who are the neighbors of this first spatial unit, but you can also check the weight of the first spatial unit. You do this, you run this, and you'll see. Remember we said, let me run it again. We said spatial unit 1 has got how many neighbors? We said it has got 5 neighbors. 2, 3, 6, 7, and 20. These are the neighbors of this first spatial unit. So now we say that this spatial matrix that we are creating, it is a spatial matrix called, it is standardized one, which means that if we sum the number, the rows, it will give us 1. So let's see now. When we also check who are the neighbors, what are the weights that are given to the neighbors of the first spatial unit. These are the weights, 0,2, 0,2, 0,2, 0,2. And if we count them, they should be 5 because there are 5 neighbors for this first spatial unit. It's 1, 2, 3, 4, 5. And if you add them, it will give you 1 because there are 5. 0,2 plus, it's 1. So you are correct. This is a standardized spatial weight matrix. That's what we said. So you can read the rest. But with this one, now that we have spatial weight matrix, you can calculate the leg, spatial leg. So spatial leg, what does that mean? You need to multiply the weight matrix with the variable of interest. That's what we are doing. There is a function called leg list W. So in that, you have to put the input is the spatial weight matrix and the variable. So when I highlight it, it gives me, I've got a spatial leg for income. So that's what I call income leg. I can even see it. It is there, income leg. If you want to see also income, you can see. You can see sometimes they are like similars. It's because they take the average of all the neighbors. So that's what it is. Let me now plot it so that you can see. This logic is for you to come to how to calculate the spatial dependence. I could have skipped this, but there is a logic that we want to achieve here. So let me plot now, because spatial dependence, we can also see it in the relationship between the leg and the variable, which is not leg, the variable itself. So it's like the relationship of what is in a municipality and what is in the neighbors. That's what the leg means. The leg means the average of the neighbors. So let's say if we are in spatial unit 1, we want to see what is the average of income in my neighbors. The average, if we are in spatial 2, what is the average income of my neighbors compared to my level of income? So that's what it means. So we can plot, we can do a scatter plot. This is the plot where we put income leg. You see this tilde. The tilde means that it's a relationship. We will see it when we are doing regression. It's a relationship. So we are regressing the relationship between income. So this one is like Y, and this one is like X, but we are doing it in a plot. Let's run it. We've done it. You can see how it appears. It appears now as a linear relationship. As you can see, yeah, it can be like linear or there are some changes, but this is how it is. You see? Yeah, let me put it big. Yeah, when you put it big, at least you can see that it resembles to a linear. If you want, you can put now, this is just a scatter plot, but you can add now the line, you know, regression line. So we can regress now. And this is a normal regression. This function is the normal regression. LM means that linear model. It's a OLS. You are doing now OLS. So let's run OLS. We run it. And let's add now this OLS that we've created into the plots. So we are saying ebb line M1. So we are taking the M1, we're adding to the plots. You see what it has done? It has added the line now. You can see there is at least a relationship, although there are some outliers like these ones, and these ones, and this one is far, but at least there is a relationship. So this relationship, the reason why we're doing this is for us to understand what we mean by spatial dependence. Spatial dependence talks also about the relationship between a variable with the variable itself, but in the neighboring spaces. Because that's what we were saying. We're saying there is spatial dependence if X in units A depends on X in the neighbors or in unit B. So dependence means that there is that linear relationship. So now you can find the coefficient of M1, it is equal to 0.68. This is the spatial dependence. But we are going to calculate it now the way we've learned yesterday. It will still be 0.68. So the reason why we're putting this is for us to understand that spatial dependence is not just anything, it's just a relationship, a linear relationship between a variable and the very same variable in the neighbor or in the average of the neighbors. Instead of taking each neighbor, we just calculate the average. And that average is calculated by using that weights matrix that we've created. So now let's calculate it. So now we are going to calculate it. Now that we understand the logic, so we are going to use a function called Moran. There is a function in SPDEP called Moran. Remember, we're talking about Moran. So we can calculate now. So the Moran, the first one is this one. Moran, it's a function. Now we put the variable. So this is univariate. So whatever you put here, it should be a vector. It shouldn't be a matrix. So that's why this is a vector, because we are saying select income in this matrix. So it will be a vector. So you put whatever you want. You put the list of the neighbors or the spatial matrix. Then you also put the length of the neighbors. So which is, like in this case, is 26, but this is another function, but it's inside the function. So the length of NB, remember NB is the list of the neighbors. Then S0, it's just the sum of all the neighbors when you sum all the weights. So it's that's how it is. Now let's run it. This one, it's just because it gives two numbers. It gives Moran. It also gives expected value. We are just interested first on Moran. So we run this. When you run this, you see there is nothing that happens here because you've assigned it to I. So now if you want to see the number, you just click on I. You see that I is 0.68, the same as the coefficient of the relationship, this one, coefficient of the regression between Y, which is income, and the spatial leg of y. You see, it's the same thing. The reason why we've done this is to show you that spatial dependence is, again, the relationship, linear relationship. It's nothing else. So it's a linear relationship between a variable and the very same variable, but with in the neighbors, but the average of the neighbors. So we've got the first thing, we've calculated the Moran. So it's 0.8, something like that. You can do yeah. So once we've done that, let me run it the second time without putting 1 here so that it gives us both. And I will explain what it means. Yeah. What is K? I can't remember what is K. I think K should be expected. Yeah, I'll remember it. Forgot about it. So this is Moran. But when you calculate this Moran this way, it doesn't tell you whether, yes, it gives you a number, but you don't know. Is it significant? Is it, you don't know. You see, you remember what we said? The null hypothesis in Moran is to say this variable is spatially random. So there is no autocorrelation or there is no spatial dependence. That's the null hypothesis. But how will you know? Because this is a statistic, there's no p-value that you see there. How will you know that what we found is really significant? So we use Moran test. Moran test, remember we said for you to do the inference for the Moran, you can use it analytically or with permutation. So Moran test is the analytical, what we were talking about analytical. So you can do the Moran test, it's a function in SPDEP. You do the same, you put your vector there, you put the spatial matrix, you put alternative greater, it's just in terms of the p-values and so forth and so on. Let's calculate it. If you want more, you can click on no, L. We've calculated it. So this is the test. And we've done the randomization, the analytical part. So what it has given us Moran standard deviates. I normally don't use this one, but the statistic itself is here. You see the statistic is the same. It's 0.68. And it has given us the expectation. So the expectation normally means what was expected if the distribution was spatially random. And it gives us also the p-value. You can see that the p-value is really smaller than even 1%. So it means that we are going to reject the null hypothesis of saying income is not spatial dependent. It's spatial dependent. When we reject the null, it means that it's spatial. That's what I was telling you to say, and I will tell you now later on to say Moran is just giving you whether you reject R, you reject spatial dependence, or you don't reject. It doesn't tell you now, from this stage, you don't know now which spatial model are you going to if you want to do the spatial regression. So you don't know. So you are left there, you just say there is spatial. And you can also interpret it in another way to say there is clustering. So similar values, which is II or low, they tend to be together. But you don't know where are those clusters. It gives you the big picture, the pattern for the all data sets, but it doesn't tell you where are those patterns. And for us to be able to see those patterns, we need to do the local spatial dependence. So here we've done using the analytical method. You can also do the permutation. Permutation use the Monte Carlo. So it's Moran MC, Moran Monte Carlo. The permutation is where you are reshuffling the numbers. Yes, Prof?
Yes. Just one second. I
yes,
just
Prof.
want how to interpret this thing properly for policy purpose. So I can say if I'm a premier of let's say the Western Cape, I can I can say we can get the income. And say the income of Johannesburg. Sorry, the income, here we are looking at income. We are in Johannesburg, and there are others around areas such as Ekurhuleni, Merafong, and so there is the income is spatially dependent. For income in Johannesburg is spatially dependent on the income of neighboring municipalities such as Ekurhuleni and Merafong. Is that how you interpret it for policy purpose? Okay. And the relationship is statistically significant. Okay. Thank you.
It's significant, yeah, it is there.
Thank you.
But what we don't know why is that the case. So that's why you need now to go and dig with a regression. Maybe if you have other information, you can explain now to say it's because, yeah, whatever. But the reality is what you've said. Yes.
Okay.
So now let's calculate now with the permutation. The permutation, we use Monte Carlo, where we are reshuffling the same information, but we change just the space. Instead of being in Johannesburg, we take 3, we put it in Ekurhuleni and see. It's just a way of saying, if we have to reshuffle this, is the pattern going to change? That's the logic. So if you want to know more about Moran and see, you can do it, but the logic is the same. But the difference now is here you see here MSIM, it's the number of simulation. We are simulating. That's where the reshuffling comes in. So I've put it up to 1,000. So when you see 111, 999, it means because the one is the one that will be done first for the normal one, then there will be the simulation. So it will be 999 plus 1, the one that is the normal one, which we did the reshuffle. So it will be 1,000. You can. It depends on the size of your variable. If you've got a variable that has got 1,000 data, if you simulate 1,000 times, your machine can stop. So you need to be cautious about it. But this one, we've got few observation. We can simulate up to 1,000. You see, it has done it very quick. And let's see it. We can see it. So you see the very statistic, but the p-value here is changing. It's just saying that even if we reshuffle, this is a pseudo. Normally, it's not the normal p-value. This is a pseudo in this case. Although we've done whatever we've done, it's still small. So we can reject the null. We can say there is spatial dependence. And what I was saying, number of simulation, it means 1 means the one that's the normal one, and the number of simulation, which is 999, which makes it 1,000. So we've done spatial dependence. So you can plot also spatial dependence. So Moran, let me plot it. Let me plot T2. You see, it gives me, these are the distribution, but this is the Moran, it's here. So everything that we can do, it can't even surpasses the Moran. So it's okay. Sometimes it makes me difficult to interpret this. I normally don't use it also. I just look at the numbers. So we are done with the spatial dependence. So let us now take the second set of data, because we're looking at that data S. Let us use a second set of data. Now, because the second data that we are going to use is a little bit big, so I need to increase the speed or the size of my memory. So that's why I'm doing this one also, so that at least I'm able to run whatever I'm going to run, because this data is big. So let me do this. So I'm loading now a file which you have, which is called FL/HR80 RDS. So the same format or the same extension, which is a R data, but this data is different. It's the homicide rate in Florida in 1980. So that's what it is. You have it. So you can load it. When we load it, you can see it appears somewhere there, but it appears with the name D. So yes, it appears with the name D, the same as S appeared also. So you can check the class of this data. It says it's also an SF data. You can check the name. The name also is, it's only one variable, which is HR80, which is homicide rate and the geometry. And you can check the dimension, which is 2 variables, as we can see, 2 variables and 67. So now let's create the list of the neighbors. We do the same like we've done with S. We do the same. We create the neighbor, the spatial matrix. I run this. I just click on it. I run again. We've run it. So now let's test the more run. We are testing now whether HR80, which is the only variable that we have, because the rest is the geometry, is spatially correlated or spatial dependence. So use the Monte Carlo simulation. The reason why I've increased my space is because now instead of doing 1,000 times, I'm doing it a little bit more than that. So which is 10,000. So you see here, we've got 4 nines. So that was the reason. So the simulation will be done 9,999 times plus 1, which is 10,000. So I'm running it.
Will it not crash our computers?
You didn't show us how to increase our space too.
No, it will not. To increase the space, you go to set C, you say 2, 1 up to 5. So it will just increase the space. It will not crash. It's a small data.
I thought that
you click on this.
I thought the set seed is a random number generator.
Yes, yes. We are doing it so that it can, yes, it's a number generator, but oh yeah, it's not, yes, you are right.
So
I'm using it because
that's not increasing the space of the computer, right?
It's not increasing the space of the computer. It's just because I'm going to use Monte Carlo, and I will use Monte Carlo up to 10,000 times. That's why I need the generation to be up to this level so that I can be able to generate different numbers. Sorry for that. Yeah. So let's see now the test 3. Test 3, you can see that this is the statistics, which is 0.1, it is positive, and statistically significant because if you take 5% level, you can reject the null hypothesis. So there is positive correlation between homicide, for homicide in one region with its neighbors. You can also plot it as we've done. I normally don't use it, but you can do that. So here it was just a repetition of the same thing that we were doing.
My values are different.
Yeah, because it's a simulation.
Sorry?
Which one did you get? Is it not because we are doing simulation? Which one did you get?
I got 0.13628 and p-value of 0.42, but yours is a bit different.
Yes. Yes, it's because of the reason could be because of the simulation. You see, mine statistic is the same. It's 0.136. You also have 136, but the p-value is different. It could be because of the simulation, but it's still less than 4. Yeah. Because you see where I've highlighted here.
Mm-hmm.
When I ran mine also, there was a time where I found 0.3.9, something like that. So it could be because of the simulation, because we are running the simulation here, Monte Carlo. So it could be that reason. But at least when it's smaller than 5, then you take it.
Okay.
Yeah. So
mine
let's
is
load
also
another
similar
data set.
to Nicholas. Yeah.
Okay. So it means that it's my computer, the simulation was different. So
yes.
let's now load another data, but this data, you don't have it on your folder. As I told you, this data, as I put here, it's called FCON. package SP data. It's not AFCON of the AFCON of the Africa Cup of Nations. No, this is we are my country is eliminated, so it's okay. It's not that. It's not that. This is African conflict. So there is data where they've calculated the conflict in Africa, armed conflict. So this is this data. This data comes with SP depth. So if you click on it, you will have the data in your. So let me. Oh, I've run it wrongly. Let me click on it. Yeah, you will also have the data called AFCON in your environment. You should have it. So if you want to know more about this data, you just click question mark AFCON. So let's go now to class. Which class is it? You see, this is a data frame. But the difference now is that when we loaded AFCON, because AFCON didn't come alone, AFCON has got other data sets, but that are separate, but they are still in that package, one package. So when we load that, it means that even the other package, the other information were also loaded. You'll notice it. Go to your environment, you will see that, let me see, it is not only AFCON, there is something called Africa.rook NB, where I'm pointing. So it means that this Africa rook NB, it's a list of neighbors of African countries where there were conflicts, which was put together with AFCON data. So every time when you load AFCON, the list of the neighbors also is loaded. So that's why it is important you read AFCON. You click on question mark, read it, then it will give you. So AFCON rook, even paper NB is also part of it. So that's why you see, here I'm checking, give me the class of Africa rook NB, because it was loaded when I was loading AFCON automatically. So when I run it, it says this is an NB. NB, please, when you are in spatial econometrics and when you are using SPDEP, when you see something belonging to the class called NB, it means that it's neighbors. It's the list of neighbors. That's what it is. So this is a list of neighbors. So let's use also the class of paper NB. It's also a class of neighbors. So we do have two objects which are class of neighbors which came with AFCON. And there is also a third one, which is AFXY. I think it will be the coordinates. They say it's a matrix array. This is a coordinate. You remember the coordinate? They were giving us array. If you want to see more, you can say AFXY. It gives you the longitude. You can see these are longitude and latitude. So we had 3 more information which came with AFCON. So they put them there just for demonstration when you are teaching spatial econometrics, so you can do that. So what we can do now, because they were given in a sense that were not bound, particularly the coordinate, so we can create also our coordinate. Let me see the names in AFCON. So I say names in AFCON. You can see that in AFCON, we also have X and Y. Normally, if you want to see what is F, you say AFCON, $. You can see that F is like longitude, the way it appears. So it's a longitude and Y it's a latitude. So if you click on question mark AFCON, that's what it will tell you. It will tell you that X is longitude, Y is latitude. So what I'm trying to show you here, can you follow me properly? What I'm trying to show here, it means that you can have a data frame, which is not spatial data yet in the format of R, but there is an information where, for instance, you have longitude and latitude. So you can consider that as a spatial data because longitude and latitude, they represent a location. So that's what I'm trying to do now. Like in FCON, we said class of FCON is a data frame. Although it is a data frame, but it has got also location information. So I can use that location information to create coordinates. So this is what I'm doing. Coordinates, I'm saying create a matrix. When I say as a matrix, so I say create a matrix, C bind. Bind meaning that you are binding the columns. C bind, column binding. You are binding the columns. And which columns? Column called X and column called Y of FCON. So I'm asking R to bind these columns. After binding them, R should should convert it as a matrix, not an array, as a matrix. So when there are two functions here, there is cbind, then there is as matrix. So the execution happens in this way. It will start first with cbind.
Sorry, is it my network or Clement's?
Everything.
It's Clement's network. We're
Then
experiencing the same thing.
Create a matrix. Yeah, it's me. I think
Clement, I think your network is.
It's me. Yes, I can. So, can you hear me now?
Yeah.
Can you hear me?
Now it's better.
It's better.
Yeah, it's better now.
Okay. No, I was saying that it's because when I'm sharing my network with my cell phone. So if someone calls me on cell phone, it does that. Sorry for that.
Okay.
Is it okay now?
Yeah.
Yeah.
Is it
Very
okay?
much okay. Yes.
Yeah. Let me repeat what I was saying. What I was saying that FCON is a data frame, but this data frame has got the information related to the location of each site. But this information is not given in the format of spatial or of the shapefile or polygons. It's just longitude and latitude in numbers. So I can also convert this in spatial. So what I do, because X is longitude and Y is latitude, I can create coordinate. I can say these are coordinates. So what I'm going to do, I'm going to bind these two columns. So I take the column of X and Y, I bind them to make them two columns. But when I bind them, I tell R, you should also convert this thing that I've binded into matrix. So that's what matrix does. So you do have two functions. You have as matrix and cbind. Cbind means column bind. So the way R works, it starts with the one that is in the middle. It's evaluated, then it goes to this one. So let me run it. When I run it, it has created a code. If you want to see code, what is code, you will see now, it will give me the numbers, a matrix. You see, this is a matrix, first column, second column. So I've done that. So now I can plot. The reason why I was doing this was for me to be able to plot fx also. Okay. Although I've done that, but we do have the coordinate already, which are in AFXY, the same. For you to see the same, let's see add chord. Can you see that these numbers are the same? They are the same. But what I did here was just to show you that even if you have the data file, the data latitude information, you can get. So that's what I've done. So let me plot like we've plotted the rest. I'm plotting this. You remember what we were plotting? Because Africa point root is a NB. This is the coordinates. So I will plot the coordinate and giving the links. See what will happen? You see the links? The coordinates are there. and the links. So this is, we are in Florida, and these are the links of the counties in Florida. I can create the spatial weight matrix because I've got already, I don't need to do the rooks or whatever. They are already there. So I'll just create a spatial weight matrix, and I'll create also the to see what is the first in the spatial matrix. Let's jump this.
I think network is challenged.
Let us, yeah, I can also create this. And create 4. And give me 1 minute. Hello?
I can hear
Hello,
you.
is it okay now?
Yes. It is okay,
Okay.
now. You? Yes.
Yeah, I've changed the network. That one was giving me problem. So I've got plan B. I went to plan B.
Okay.
If it also gives problem, we'll also come back to plan A. Okay, thanks. So let me start sharing again my screen. So what I was saying, we've created different spatial matrices, 1, 2, 3, and 4. So if you want to see what it is, you can see it. So now let us see, because the variable that we are interested in is AFCON, a total AFCON. So it's a total number of conflicts. That's the variable. We want to do, look at the histogram.
Okay. Can you share your screen, Clement? Clement? I think, is it me or Clement? It seems like it's Clement.
It's not you, it's Clement.
Yes,
Yeah, I'm also here.
Okay.
I hope he is safe.
I hope so too.
We're only 10 of us remaining.
Sorry.
Yeah, this is survivor of the fittest, no?
Yes.
Prof. Eta, those of us that are remaining, what is it that is going to be given to us?
Huh? Oh, Charles.
Yes, sir.
How are you?
It looks like those who are remaining are hoping that at the end they will distribute prize.
Yeah. There will be prize to be given at the end of the workshop. So just make sure that you don't leave, because Koketo is going to distribute prizes.
Okay.
Yes.
Don't put Koketo into trouble, because we are taking you serious.
I was about to say, I didn't promise anything.
Koketo, I'm coming to your office for my prize, because I've been so from the beginning.
It's most probably going to be a handshake.
Is that the prize?
Yes.
Yo. All right. I think it's a golden handshake, no?
Yes, there you go.
Yeah.
And that's fine.
But while we are waiting for Clement to come back, I think I can actually see that R is such a very powerful software. Very, very powerful software. There is so much that you can do. I'm using it for the first time, and I like and have enjoyed what I have seen so far.
Yeah, Prof, you are right.
Yeah.
I
Have
like,
you used it before, Charles?
yeah, I'm planning to plot some graphs.
Okay.
Yeah, I like the way it presents its graph. The graph are so nice.
Yes.
Yeah.
Yes.
Afternoon, Professor.
Afternoon, Olivier.
Yes, Prof. No,
How are
I'm
you?
familiar with R myself. I am good, Prof.
Oh,
I'm
okay.
familiar with R myself.
Oh, okay. So
It's
this
not-
one is just you are more interested in the spatial econometrics, not the software itself.
I've discovered
not
what,
really. Yeah.
I'm really sorry. I had a problem. I've discovered what was it. I'm back now. I'm really sorry for what has happened. I don't know what was going on, but I've managed to do that. Let me share my screen again. Yeah, sorry for those. Yeah, so I was here. I was saying that I'm running. I want to test this variable called total conflict, tot_con, to see the distribution. When you run it, you can see that it's skewed to the left, as we can see. So this is not a normal distributed kind of variable. So instead of using it, I'm going to log it so that I can at least linearize it. So let me see the log. When you log it, you see what appears. At least the form is like kind of normally distributed. So forget about all these. Let me check if they are missing values. There's no missing values. So let me check the minimum of AFCON. There it is, so forth and so on. So now I'm transforming the data. I transform it and have added it. So let me explain this, what I've done here. What I've done here, check properly. FCON didn't have log of total FCON. So what I've done, I've created a new variable which is called log tot_con. So I'm telling whatever will happen here, you go and put it in FCON, but it should be in the variable called log tot_con, meaning that I'm adding a new variable that I'm creating. So that's what I've done. So I've logged this variable, but once I've logged it, the outcome, I'm telling R, take that outcome, go and create a new variable in FCON and add it as a variable. So that's what has happened. So I've added now. So that's why when you see now here, there is a new variable called log tot_con, which was not there because I've created it using this. The same way as you do in Stata when you say generates and so forth and so on. So you can do the same. So now what I want to do, I want to do the spatial dependence. I run this function, I call it X. I create list. Then let me run it. So you can let us go faster. You can run this on your own later. You're just going faster so that we have time. Then I label it. Let me create. And let me plot. Let me just run this quickly so that it gives. So what I've done what we call Moran plots so that I can see the values that are high, low, and high, low, and low I. So these variables here, this space here, I, low, I, low, and low I. So that's what it is, but forget about it. Let us progress because we are late. So let me create just the lag of FCON as we've done. Instead of using 2, I'm going to use 1. So let me just create this one like we've done with income. We create it and let's plot it. We plot it. You see, it is not really, giving us a new thing, but let's do what we've done and let's do this. And we've got already a coefficient of dependence, which will be 0.24. But now let's calculate the spatial dependence itself the way we do it. So I'm using this function. I calculate it. Then when you click there, it is still 0.20.24. So I can run the same here. So test 1 is significant. So there is spatial dependence because we can reject and it's positive. I hope you are following me. So you can do for the rest. For the rest, it can do it. So yeah, we've done it for spatial dependence. So that's how you do it in Moran. Giri, the same, but we are not going to use it, but it's there. I've put it for you. You can do it on your own. So let us now look at local spatial dependence because we don't have time. We need to go now to the estimation. Local spatial dependence, let's load this variable, which we have already loaded, which is Florida HR80. So we can load it again, but it's already there. So let's plot. We've already plotted. I don't want to plot it again. Let's create the neighbors. We can create the neighbors for Florida. We can create the spatial weight matrix is there. And we can create this one. But let's create the global, first of all, the global spatial dependence. This is the global spatial dependence. I call it global. Here is global. So it is 18 something. So we can, we can even create MC. So there is global spatial dependence. It's taking time. Can you notice that this one is gonna take time because I am now simulating 10,000 times. So that's why it took long. So global Florida MC, you can see it's 0.3. We reject the null hypothesis. So there is spatial dependence, but we don't know where this the clusters. So that's why, can you follow me here? Because this one is new. We are now calculating the local Moran. The function which I've highlighted is called local Moran. So the difference is just the function. What is needed, you need to put the variable and the spatial weight matrix. This is spatial weight matrix. So the difference is just a local. The function which says local Moran. When you run it, it has already executed. Now, if you want to see it, it will give you a list of all the spaces you see, because we've got 67, it's from 1 up to 67. So these are the local Morans. Like this one is negative. Remember when we run this global, it says positive. But here it gives us, this is a negative. Fortunately, it's not significant. Let's see which one is significant. So the one that are significant, it's here. You see, for instance, here, it's significant. Here also it's significant. Here also it's significant. So you can see that when you go locally, you can find that some places locally, they are not significant, whereas the global pattern is significant. So that's the challenge that we said depending on the work that you are doing, you need to know what you are doing, because if you are working with crime or whatever, it can bring you this confusion. So we are done with practical number the 2, 3. I want to open 2, 4 so that we finish at 5. So the one that I'm going to open is now we are going to run the regression. Is that okay?
Clement, I think we can go along, but I didn't follow the global. I got error messages.
Okay, can we see can you show us your slide? Let me stop sharing. I've already stopped here. Can you please share your screen, Prof. Ngepa?
All right. You see, all from the globals, I started having errors here.
Yeah, let me see what errors is. Yeah, you see the errors. When you read errors, you see the last, you say objects LF not found. So it means that you didn't create the spatial weight matrix. That way you missed this one. You didn't create this spatial weight matrix. So can you stop? Yeah. Can you stop it? I will show you where it is. Yeah, thanks. So let me go back again there. Here we are. So we are here. We were here, Prof. Let me go back again. Yeah. So we were here. We've already loaded this data. It is already there. So we don't have a problem. So now we are creating a new list for Florida. So you need to select this. You see it's NBFL. We didn't have it.
Okay.
You've got it already. Or you can just highlight it and run it. It's not a problem. It will just overwrite.
Okay. Well, I have to first load the data.
No, the data is already there. You've got this data because it was the second data that we've loaded. It's D, data D. So you do have it. Just select, it will run. Select and run, it will do.
Okay, let me see now. I did, let me over. Yes, I'm not getting the errors anymore. Thank you. Yeah.
Then you select now. That is the list. Now you need to do the spatial weight matrix, what I've selected, the LW_FL. So it's another spatial weight matrix that I've created now. So you need to select and run it.
Mm-hmm. I've just done it.
Then the rest you can run it. It will run also. So you can run the global. Go to global now. Go to global.
Yeah, the global. Run. Yeah.
Yes. Then you can also go to local. It will run.
Okay. Thanks.
Sure. Pleasure, sir. And now we need to run the regression. I'm very sorry we are left with 1 hour. Let's run the regression now. So the regression is in practical 3.2. So you go to session, so you can eliminate everything that is there. I'm cleaning it. So you go to session, you go to set working directory, and you choose directory, this one. Then you go to day 1 and go to practical 3.2. So you are now in practical 2.2. When you are there, go and open MyLab 3.2, not solution, MyLab 3.2. You open MyLab 3.2. So this is what you have. You should have something similar to this, which says practical session 3.2, estimation of spatial effect model with maximum likelihood. You should have this. So ignore this. You ignore this, what I'm highlighting. You can even put there something, you ignore it. Don't call the library anymore because they are already there. You didn't close your session, you just change the location. So SPDEP and spatial reg, they are already there. So you don't have to bother yourself. So now,
sorry, Clement.
yes,
Sorry, Clement.
Prof?
I just want to make sure that I do things the right way. I think that's yeah. So I went to session, then directory, choose directory. I go to day 1, and then I select practical 3.2.
Yes.
And then there is a folder that appears practical 3.2. I don't do anything. I just click open.
Yeah, you don't even select, just click open. Yes.
Okay. And then I have opened it. And then let me just see. I just want to see what you have there. So that's all.
Yes. You don't have to select. Let me show you from my side. See from my side, Prof.
Okay.
I go to session.
Okay.
I go to set working directory. I go to choose directory. You see, it leads me here. So there is nothing here because it's practical too. In your case, you were here. You were here. You have to go to day 1 and practical 2. You just click it and say open. That's all.
Okay.
Yeah.
Okay. No, I did.
So now
I've done it the right way. Thank you.
Okay. You come to R, go to R and open MyLab, a script called MyLab 3.3_2. Oh, this time it's 3_.
Okay.
You open 3_2. And when you open it, you will see that there is library, SPDEP, and library spatial leg. You don't call library again because they are already there. We didn't change the session. We just changed the location. So you don't have to call it. So now we are going to call data called Boston. So you see, in this case, we just say data Boston. It means that SPDEP has got already, because SPDEP is already in our session, and this data Boston is part of SPDEP, we are not going to call it. We just say data Boston. So when you click here, you are right here, and you run it, you will see that Boston will just appear in your environment. So this data is connected to SPDEP. Once you call SPDEP, this data is already there. You are just going to import it. So you import it. You see that when you import it, it gives you 3 folders: Boston.c, Boston.soe, Boston.utmi. So these are different things. So if you want to see which are these things, you also use class. So you put class Boston. So tell you which is Boston. It says, I don't know Boston, because it says Boston not found. And it is right, because Boston is not here. What we have, although we called Boston, but what R gave us, it's not Boston. R gave us Boston.c, Boston.soi, and Boston.utm. So then let's see what is in Boston.c. Boston.c, they say it's a data frame. You can see, let's see Boston SOI. Boston SOI, they say it's list of neighbors, NB. What about Boston UTM? Boston UTM, it's a matrix of array, which is it means that these are coordinates. You remember the coordinate the way they are? So we know now that Boston C is our data frame. So let's look at the dimension of Boston C. They say the dimension is 506 observations to 20 variables or columns. So let's see the names. What are the names of these variables? They say town, town number, track, longitude, latitude. You see, although it is data frame, we also have the location here. You see longitude and latitude. Then they give us medium, value, crime, whatever. Medium value, CMDEV, I don't know, crime, ZN, industrial, and so forth and so on. So now what I want just to select data from column 4 up to 20. 4 start from here, 1, 2, 3, 4. So longitude up to the last one. So you remember we did the selection. So I create now a new object, which is D. I select the data, D is there. So now give me the name of D. It gives me the name of D. You see the short. So dimension of D is N. So now, those who were asking me the graph and so forth. This is another package to do the graph. It is called leaflet. Instead of, like in the case of team map was only doing things when the object is of the format SF, you see? But leaflet is good. It can work with any kind of set of data. It's very nice because it's even interactive. So you can call this as a library, call team leaflet. So what I'm trying to do, leaflet works like tidyverse, the one that we've done. Remember, we've done tidyf this morning, where you work with pipes. So it works also similarly, but here, I'm not going to explain much because it will take time. I just want to run to our thing, but I can run this function. You will see what it will do. You see what it has done? It has created the map, but this is an interactive map, the real map, where it gives you Boston. You can see the ocean is there. You can see other things. So this is the real map, if you want to do it. So leaflet can do that. So you can go and learn how to do leaflets. Let's jump it. Let's come now to regression. We are going to do our first regression. So we do have the data sets, which is in Boston, C, and the list of neighbors is in Boston, SOI, and the coordinates are in Boston, UTM. As I told you, you can have data in separate objects, but still do the analysis, even if they are not together. You can do that, provided that they respond in terms of the names and all those things, they correspond. Otherwise, it will give you an error. So let us run a linear regression model. A linear regression model, as I told you, it is, you don't even need the package. It is a basic thing in R. You don't need the package. It's called LM, linear model. So that is how, this is the function, LM. Then we put brackets, then you put the formula. We call normally this the formula. Formula, what does that mean? The first one on your left-hand side of the tilde is the dependent variable. Whatever will follow here are the predictors. So like in this case, we are saying same dev, can't remember again what was it. Is it, I think it should be related to medium value, something like that. Value of the house, yes. Value of the house, but medium value. So this is our Y. The first X is crime level in the city or in the county. Distance to the city center, and indus, I can't remember what is indus again. Then after you put the formula, you put comma. Yeah, after you put the comma, you need to tell R which data I'm going to use. So I'm telling R, use the data which is called D, the data that we've created. So you just select it and run. There you are. Your first function in R, you've run a linear model. And you can see summary. Summary gives you summary function, it prints for you the results. So you can do summary. You can see the results are there. Let's see them. So it tells you that this is the function that you've run, and it tells you the distribution of the residual. You can see if you want to examine the residual, then it gives you the coefficients. So you have the estimate, standard error, t-value, p-values, you see, And R gives you even this, say where it is, you see 3 stars, it means that's significant at 0. When you see 2, it's significant at 0,001. When it's 1, 0, so that's what R does. So it gives you everything. Like you can see that crime is negatively related to the value, the median value of the house in a city. So that's what it is, and it's significant. So we've done our first model. You can do the other things. So now we want to do a spatial regression. We need, for us to do spatial regression, we need spatial weight matrix. And we are not going to create again the list of the neighbors because we know that the list of neighbor is what is called Boston.SOI. So we just use Boston.OI, we create the list of neighbors. And you can see here, I didn't put queen or whatever. So by default, when you don't put it, it says queen it's a queen. That's what it is. So you need to put, if it's not queen, you say queen first. But if you don't put it by default, it assumes that you are working with queen. So we are assuming, then we click there, it creates a weight matrix. So we are now going to use to estimate spatial lag model. You remember the spatial lag where you've got only the interaction in the dependent variable, which is y. So the function to do a spatial lag model is lag sar lam, lag sar lm. So lag spatial autoregressive linear model. That's why they got this abbreviation. So you have this as a function, you have this as a formula, the same as we did for linear model, but you are adding now the list of weights or the neighbors or the spatial weight matrix. You add it there. So we say list W is equal to this one because it's there, we've created it. So we are telling R to say our spatial weight matrix is what we've created here, and data is D. So you see, data is in somewhere else. The spatial weight matrix, we created it using something else, but they are similar. Then the method here, it's just in terms of computation. It's just, I didn't go into detail. It could be eigenvalues, it could be matrix, it could be something else. So we are going to run this model. We just highlight it and you click on run. It's running now the model. So this is this first spatial regression that we've done. So it's there. If you want to see, you can also print the results, the summary. Here you say summary, print for me. It has printed for you. Let me put it big now. It has printed for you. The first line is telling you the model that you've done, or so the call, whatever you've put there, it gives you so that you can see whether you've made a mistake or not. The residual also, it gives you the form. Now you can see type of the model. So this is a lag model, spatial lag. That's why it says type, spatial lag. Now it gives you the estimate, and these standard errors are asymptotic. It tells you these are asymptotic, so you don't have to worry and so forth and so on. So you can see that they are there. They are also significant. You can see in this case, it's not telling you the star. Error, some doesn't tell, but you can see that it's significantly related. But they are different. They are different. Let me print both of them. Let me print the linear model and the rest so that we can compare them. So I'm printing the linear model and I'm printing also this one. You can see the linear model, the relationship was still negative. Even here, the relationship is still negative, but the difference is just the magnitude. This one is also significant. This one is significant, and so forth and so on. But what is important is you need, first of all, to start with your lambda. The lambda, which was, we said, spatial autoregressive coefficient, to show you the dependence in the dependent variable. So that's what I was telling you. When they report, they don't call it lambda, they call it rho. So be aware of it. Although it's spatial lag model, but they say it rho, normally it's lambda according, so it depends. Somewhere they say it's lambda, others they say, so don't worry about it. So you see, this is the value of lambda. So the average of the neighbors for each municipality, this is it. So if you can interpret it, you can say, if there is change of the value of the house in the neighboring municipalities by this amount, by one, let's say $1, then it means that the value, the median value of a house in the space or in a state I will be 0.1, because that's what it is. So now you also look at, we were supposed to look at these things, but because of time, you also need to look at the significance of this. So there are three ways of doing it. You can either look at the LRA test, or you can look at the world test, or you can use Lagrange multiplier test. First of all, the test, let me go slowly here. Prof, you want to say something?
Yes, I wanted to say, when you were explaining raw 0.7, I just want to say, if there is an, can one say if there is an increase in the value of house in Ekurhuleni? So yes, what will happen to Johannesburg or Merafong? I just want to maybe just say something there.
It says this, if the average value of the neighbors of Johannesburg, which are Merafong and Ekurhuleni, if the average value of the house is, let's say, $1, it means that in Johannesburg, the value of the house will increase by this amount.
Oh, good.
By this amount, yes.
Thank you.
0.7.
Okay.
So now, let me go very slowly here so that I can explain, because this is part of what is now in the last part of our slide. You need to test now the significance of this. So how do you test the significance? First of all, in spatial econometrics, there are different ways of doing it. The first one, you need to estimate. You need to estimate the linear model, which is the OLS, because OLS is always the departure point of us. You estimate the OLS. OLS, we call it, in this case, the constraint model. And spatial leg, like in this case, we have spatial leg, we call it unconstrained. Why are we calling it unconstrained? Because we assume that it's a true model which takes into account the spatial dependence. Whereas OLS is the constraint model which does not take into account the spatial dependence. So now you can run the OLS, then you estimate the spatial dependence in the error terms. Remember, what we were doing so far was the spatial dependence of just a variable. Now, for the estimation of the model, you can estimate the linear model with OLS. You test for spatial dependence in the error terms, because one of the conditions is to say there is no correlation between error terms. So you take the residual, then you test for spatial dependence using the Moran. It's similar kind of things, but they are different. Here, you are using the residual, but in the other case, you are using a variable. So for linear model, you are going to use the residual and you test whether there is spatial dependence. If there is spatial dependence, then you are going to, if let's say your Moran is significant, it means that you reject the hypothesis that there is no spatial dependence. So now you need to go to the next stage. So to the next stage, you can estimate a spatial leg model like we've done now here. Once you estimate a spatial leg model, it gives you the row, the value of the row. How do you know that this row is significant? So you can also do the test. The other test you can do is LRA, likelihood ratio test. and you can also do wall test. The difference between LR test and wall test is that for likelihood ratio test, you need to estimate both models. You need to estimate the linear model, which is the constraint and the unconstrained. Then you compare the likelihood. But the good thing of it is that the function that we've just run here does that for us without us running the linear model again. So it means in the background, it has also run the linear model, and it has calculated the likelihood ratio, and it has given us the likelihood ratio. And this is the likelihood ratio. And you remember the test is always a null hypothesis. It means that there is spatial dependence. And the alternative is there is no spatial. So it has run it to mean that when we take this LRA test, it means that this LRA test normally was supposed to be done by comparing linear model and the spatial leg. So by doing that, we reject the null hypothesis which says there is no spatial dependence in the residual of the linear model. So if you reject, then we say this is good. So it means that this is significant. So that's what it means. So this is what we call LRA test. So even this one the same, but I normally use this one myself. I prefer to use this one. So sorry, I'm going very fast because I was supposed to go slowly with you here, but this is how you do the LRA test. And this is where you were comparing just the linear and the spatial. But the rest of the part here, like here, it has also done the LM test for the residual, but in the spatial leg model. So there is no residual, as you can see, because it's greater than 0.5. So this model is perfect. So we can take this model. But when you go in my notes, even in practical number 5, you will see that I've explained all these things. So this is the first that we've done. You can also now run, let me skip this. You can run now what we call, like here, the difference between what we've run is just the method. Here we've used eigen. Here you can use matrix. You can use LY, LU, MC, Chebyshev, whatever, but eigen is the default. I normally use this one. I don't want to complicate my life with many things. I just use this one, and the rest I forget. So you can, if you are doing an experiment, you can run all these ones, then you compare their result, or that's what I've done here. So if you run these things, it will lead you to compare the result and to choose either using the IC or something else, so that you say, okay, this one is the best. So that's what I've done. You can use IC here, and you know the logic. I'm not going to do it. Let us now go to the second model. The second model that we're going to estimate is what we call SDM, Spatial Debit Model. You remember the Spatial Debit Model? The interaction is in the dependent variable and in the axis. You remember? You can, where we gave an example of poverty and unemployment in Santon. So there is interaction not only in the dependent variable, but there is also interaction in the axis. So that's what we call Spatial Debit Model, but I've just abbreviated them to say SDM. So we use the same function of the one that we've used for spatial leg model. The only difference is that we've added this. So there is what we say Deben. When we say true, it means that it's going to run Deben. The default is false. So if you don't put it, it will be spatial leg. But if you put it and you want to run SDM, you need to say true. That's what we've done, true. So let's use it. And it also differs in terms of whether you are using matrix, eigen, or so forth and so on. So we're gonna just run this one. We run it. You see, very quick, it's already there. If you want to see the result, you click there, you see the result. These are the results. So let me put it in big now. So these are the results. First of all, you see crime is there. So this is crime in space I, explaining why in space I. This is distance in space I, explaining why in space I, industrial and so forth. But we've also added the legs of the excess. That's why you see now it's reporting here to say leg of crime. So this leg, it's leg of crime. It means that crime level, the average level of crime in the neighboring states or municipalities or spatial units. So that's what it means. The same applies to distance, the same applies to industrial. So this is a spatial Debit model. So you can also interpret it. You can also interpret the row, which is lambda, the very same way that we've interpreted this one to say, if we use likelihood ratio, it means that we are comparing this model with the linear model, which is the OLS, then it means that this model is better because there it is. Then, and so forth and so on. So you can now see that that's how we do spatial Debit model and the spatial leg. You can use one function. So now what I've done here, I've just done the same like I was doing earlier on to compare the result. So you can also now run the spatial error model. You remember the spatial error model? It's a model where the spatial interaction takes place in the error term. So that's what we call spatial error term. And the function is error spatial autoregressive linear model. So it's different. If you want to know it, you can just click here, it will give you. In terms of the syntax, the same, you put the spatial matrix, you put the same. Even the method, you can say also eigen. So what changes is just the name of the function. You can run it, and you can do summary. It gives you the summary. You can see now here it's giving us lambda instead of row. That's what I was saying. So it's changing. So you can compare now this LRA with the linear model. Although for you to do likelihood ratio, you need to run both models, the constraint, the unconstrained. But in this case, R has done the work for us, and it's just given us the statistic instead of showing us the result. But you can see that we can reject the null hypothesis of non-spatial dependence in the linear model. So this model is good. We can do it and we can assess it and so forth and so on. So we've run the spatial error model, the spatial Debit model, and the spatial lag model. So there is also another model which is called spatial error Debit model. But before we go there, yeah, this is it. Well, there it is. Like in the case of spatial Debit model, spatial Debit error model, it means the interactions happen in the excess and in the error term. Whereas spatial Debit model, the interaction was happening in the dependent variable and in the excess. So please try to understand that's the difference. So you are using the same function, but you also put Debit and you say true and you run it. And when you run it, it's there, it's running, it's finished. Then you can see the summary. You have lambda, which is the interaction in the error term. You can see that it's significant. But when you come to excess, you also see that the excess are given there. You can just assess them, like this one is significant, and so forth and so on. So that's how you do. Is there any question? No. So let's go now to the general model. You remember what we call the SARR model, the general one, the one that encompasses both, the three things. So the interaction in the dependent variable, in the excess, and in the error terms. So the SARR. So the SARR model, this is So I've given the SARR model. You see where I'm highlighting. You see there is rho, there is X beta, there is lambda. Normally there should be something here. So there is a mistake. I should put also something here. Let me run it. The function is SAC SARLAM. It means that spatial autoregressive correlated SAR, whatever. So this is what it is. It's a different function. It's part of SPDEP. So you can run it in terms of the input, the same, nothing changes. What changes is just the name of the function. So far, we can see that there is similarity in terms of the syntax. It's only the name of the function. And if you know, you need to know the name of the function, what it is, you can just click here. So let's run this. We have run this. This one takes a little bit longer, but now it is done. Let's click on summary. We click on summary. Let's see the values. You will see that it will give us rho and lambda. You see the rho is there and the lambda is there. Rho is what is for the dependent variable. Lambda is what is in the error term. So let's see you can assess it also by using the p-values asymptotic. So there it is. Let me see. Yeah, the LRA first of all is there. It's giving us the LRA. You can see it's there. So it's a good model. So yeah, it's a good model. Yeah, it's a good model. So the logic is the same. What changes is just the differences in the terms of the model. So let's run the last model. You remember the last model? We don't want the interaction in the error term or the interaction in the dependent variable, but we want the interaction in the X's. What we said, it's called spatial Debye linear model, or what is also called spatial lag of predictors. So this is it. There is a new function. You see it's LM SLX. This is new. It came in 2009. Otherwise, people were using just the LM. They were just using LM, but you can use this one. And it gives you can do the summary and so forth and so on. So we've done the regression using this variable. But I want to talk about two things that are very, very important. The first one is the interpretation. Which interpretation? The interpretation of spatial lag model, spatial Debye model, and SARR model. So I want to talk about it. Let me start with spatial lag model. This is very important. I will go slow because I know we've got 30 minutes. I'm not going to rush. I will just go slowly so that I explain it. Let me first click here so that we can have the spatial lag model. Normally, these are the figures. So if you want to interpret for the row, we know what we've already interpreted it. So there's no problem. The interpretation that I'm talking about is the interpretation for this coefficient here. Normally, in a linear model, you interpret this as the, like the derivation. When say if something changes by unit 1 in crime, for instance, this will be the, let's say, the increase. Like in this case, it will be the decrease. If there is increase in the crime rates, it leads to the decrease of the value of the house. It makes sense, isn't it? But you don't interpret this in this way. You don't use this estimate as they are in terms of their magnitude to interpret. Why? It's because if our rho here is significant, what is rho? Rho is telling us that there is interaction in terms of the dependent variable, the value of the house. So the value of the house in Johannesburg depend also of the average value of the neighbors, which are Ekurhuleni and Mfuleni. So if there is crime in Johannesburg, we want to see the impact of crime in Johannesburg. the impact of crime on the price of houses in Johannesburg. Of course, crime will affect the price of houses in Johannesburg, but because the price of Johannesburg is also affecting the price of houses in other jurisdictions. So that effect will not stop in Johannesburg. It will first go to Johannesburg, then it goes because it's Y now. Y in Johannesburg is affected. Then Y in Johannesburg affect also Y in other jurisdictions, or Y in other jurisdictions affect Y in Johannesburg. So there is that feedback. So because of that feedback, you cannot interpret this one, because this one is just in one way. It's just affecting Y here, whereas there is feedback. It goes here, then it goes first to the neighbors, then it comes back. So because of that, you cannot interpret the magnitude of these values. So you need to do what we call total effects. You need to separate what is the direct effect of crime to Y in Johannesburg. So we call direct. What is the indirect? Indirect means the fact that crime in Johannesburg affects crime. Oh, no. The fact that the price of Johannesburg is affected by the price in the neighboring municipalities. It means that when the crime in those neighboring municipalities affects those neighbors, the price of the neighbors, that price is included in the Y, and it also comes in Johannesburg to affect the Y in Johannesburg. And we call it indirect. It's an indirect effect. The total effect is the effect for both. So you need to calculate the total effect, the indirect effect, and the direct effect. Then you interpret those. So in the slide that I've given you, you will see that the last topic is talking about it, and that's the part in practical number 4. Practical number 4 talks about it so that you can see how to interpret. This only applies for spatial leg model, for spatial Debye model, and for SARA. Why? It's because spatial Debye model, there is also interaction in the Y, in the dependent variable. In the SARA, there is also interaction in the dependent variable. So I've explained that part, but you can read my slide. You can also follow the examples that I've given, how to interpret, and it will. And there is, you don't have to go and calculate it on your own. There are functions to go and calculate it. So in practical number 2, you'll see the function, how to calculate it. So that's the first thing. I don't know if at this stage, if there is a question before I go to the last topic. Okay. The last topic is, I've already touched on it. It's now in terms of the estimation. There is a problem, or not a problem, there is a debate in spatial econometrics in terms of the procedure. How do you estimate? There are two different schools of thought. The first one says the procedure that you should follow is what we call from the general to the specific. So you start with the general model, which is the one that I've given you, SARA, which is the example that I've given you, which is the procedure that I've given you to say you estimate the SARA model, then you start cutting it in terms of imposing the restrictions until it leads you to something. There is another school of thought that says you need to start with the unconstrained model, the constrained model, so that you can build that up to the general model. So which means that the linear model, then you go to check whether spatial model is good, you estimate spatial model, even spatial model, you're gonna estimate a spatial leg and the spatial error model, you compare the two, then you go until you go up there. So this is a school of thought. So depending on the school of thought, it will also determine how you apply, how you do the test. So let's say you follow the school of thought which says follow the where you start with the linear model, then you go to the spatial. Normally, if you check properly, these functions, that's how they are built. They are built following that approach of saying that you need first to estimate the linear model. You test the linear model in terms of whether the residual, you do have spatial dependence or not. Once you have spatial dependence, you use another test which we call Lagrange multiplier, developed by Luc and Clement. He's also one of the fathers in spatial econometrics. That test will tell you whether spatial lag is advisable or spatial error model, and so forth and so on, until you go up. But the another school, like Abia, the book that I showed you, is saying you just estimate the big model and you test the big model to say whether the parameters that you have, particularly for spatial dependence, they are significant. Then it means that they are significant. Like in this case, look at this model, SLM, that we have here. Let's assume that we didn't have a spatial linear model. If we estimate this row and we say that it's significant, then it's okay. You can interpret it and put it there because it has given us the LRA. Or even if the LR was not there, you could have used IC also. You can also use this one also. You can see, for instance, it's reporting IC even for the LM. You can see if you compare the IC, you see this one is bigger than this one. Already you can see from here that if I have to choose, I will choose spatial lag because the IC of LM is big, is 3503, whereas this one is 3192. So this is the logic. And okay, now I'm giving you my preference. Before I was on that other school, but now I came to realize that this school makes a little bit sense. So I'm following this, but I'm not saying it's a correct one. There is no correct, it's just a way of doing things. So what we miss now is to do the test of the dependent variable, of the residual in the LM. So you need to do also that. Although they are already reported here, but we can also do that. We can also do that using Moran. So let me stop here and take questions because I've talked about big topics very quickly. I suspect that there might be some questions. So let me stop and take questions. Oh, there are no questions. Thank you very much. So we were supposed to see all that. Sorry?
How do you export results of regressions from R?
Yeah, that's the problem. You need, it's something that I'm also learning. There are some challenges. So what I normally do, let me see if I've got it here or not. Yeah, that's the challenge. You need other you need other packages to go and create the tables and so forth and so on. So it's a disadvantage that R has compared to Stata, because in Stata you can just click on the button and it copies as a yeah, that's the challenge. Let me see if I've done that. I didn't see it, but it's a challenge. I agree with you. There is a way of doing it, but it's very tidy. Yeah, it's a way, yeah, like here, I can do, yeah, even this one. You see here, I've done, because like here, I'm combining now. I'm saying, take this, because this is spatial lag model, and I get the coefficient of this one also, the coefficient of this one, and I bind them, I put them in this. Once I put them in this, I can save this as a matrix, as Excel, so that I can go and open it in Excel and start copying. So it's very, to tell you the truth, I don't know how to do it, but normally that's how I do it, and copy, and it's very, it's really tiring for me to do that. But there should be other other packages that we can use to do it quickly. I'm not aware of that, but they exist. I'm very sure that they are there. So can I take another question if there is one? So what I will ask you is that we were supposed to do, we are left with 15 minutes. I'm going to open a practical where we do the testing. We can do just one. The rest you can do it yourself so that you can see. So now in terms of the GLS two-stage least squares, I will also open and show you which file you can use and which functions, but I'm not going to run it. So that's what I'm going to do so that you can see. But in my notes, not both in this presentation and particularly in the practical, I've explained all these things so you can be able to do it. If you encounter a problem, please let me know and I can arrange how we can do it. So that's what I'm going to do. Let me now open. I will just open another practical number, I think the one that we're working on is 3. So we need to open 4. In 15 minutes, we'll be done. So let me, I'm sharing the screen now again with you. Yo, my mouse now is misbehaving. So let me go to session. I'm changing my session so that I can go where practical number 4 is. Day 1. Day 1 we are finished. So we go to day 2. Day 2, practical number 4. I click there. So let me save. Don't save. Don't save. Don't save. I'm just closing my things. Don't worry. So now I'm opening my lab 4. So I'm opening my lab 4. My lab 4 is to estimate with two-stage least squares and GMM. So the package that you need, first of all, you need this one. You don't need to install it, but you need a package called also SP. Let me check where we are calling it. Wow, I made a mistake or what? Okay. But normally you also need this package. Maybe I remember now, that package was also put here. You will need this package. I'm putting it so that you can see. I'll put it on the chat box. You need this package, SPHT. You also need that. It's also important. I will put it in the chat later. So once you do that, you can do the same data. You see here, we are estimating spatial leg model, but not with maximum likelihood, but we are estimating it with two-stage least squares. So it is STS-LS, different from lag-SAR-LAM. So you can run. When you look at this, it's the same. Because I've got the data already here, let me just run it and see what will happen. So I've run it, and let's see. Let me do the summary. The summary is there. Remember, I didn't remove everything, so let me do the summary of SAR-LAM. If I do the summary of spatial leg eigen, this was run using, so I've got now the 2. So I've got this one is maximum likelihood, but this one is two-stage least squares. You can see the difference in terms of this one report the rows because these are written by different functions. So the rows is included as a coefficient. So you see the row is there, and let's check the row. And the row here is bigger. No, here is bigger. There it's small. So those are the small differences. Check also the intercept. Here it's 21, whereas here it's 13. So those are the small differences. It depends on the method and the imputation that you are doing. But the challenge is that this one does not give you the likelihood test. So it means that if you want to do this, you'll have to calculate the likelihood test, whereas here it gives you already, so you don't need to calculate, you just report your data as they are without going that route again. So that's the first thing that we can do. So the second, let me see the second one. The second one is for the spatial error model. You can also do the same. This is the function, and so forth and so on. And for GLS, this is the function. You can do the same. So now I want to open the one that says for testing in 10 minutes. Let me open the session called Practical 5, where we have the testing, the one that I was talking about. So let me open it. My lab 5. When you open my lab 5, it says specification and diagnostic and so forth and so on. So you can put all these things. It's okay. You can call the Columbus. It's okay. So for you to test the residual in the linear model, remember linear model with OLS, you use LM Moran test. The rest, what we're doing Moran test, it was different. This is LM, meaning that we are testing the spatial dependence in the residual of LM, linear model. That's why they even put linear model. You remember we had our linear model, which we called linear model. So we can do it here. I'm just putting it here. So it's not OLS, it's linear model. So it's linear model, so it's LM model. And the spatial leg was, if I remember well, the spatial leg was, what was the spatial leg again? It was, yeah, I can't remember again. It was, let me go back to it and see what was the spatial leg. I'm just coming back to it again. Let me see what was the spatial leg. The spatial leg is W lists W. So it's W, oh, sorry, it is W lists W. So it's okay, I'm running the test. So this is the test. I've run the test in the linear model that I've done using practical 3.2. So let me now see it. What is it? So let me see the answer that it gives me. So it gives me, this is the statistics, and this is the p-value. Remember when we looked at likelihood ratio test, when we ran the SLM, we said there is spatial dependence in the error, in the residual of the LM. It confirms here also. There is spatial dependence. So you can see that instead of running this Moran, you can just do that regression because the result will be the same. The answer will be the same. So that's how it is. But for the purpose of people who follow the other school of thought, you need to do it. But at this stage, you don't know whether it's spatial leg or spatial error model. Whereas for me, I can run all the model and look just at IEC and choose the model that is best for me. Whether it will be spatial error model, spatial Debian model, spatial Debian error model. So I will look at the IEC of these things. That's what I do normally. But in this case, if you follow this example, it means that you need to run them and try to see again. Now, there is one last point that I want to emphasize on. When you are doing the Moran tests for the residual of the OLS model or the linear model, don't do the permutation. Most of the people I've seen, even some papers, they've done that. You can't do the permutation. The logic is simple. It's because you've run first the model based on things as they are. So why do you do the permutation? Permutation is only allowed when you are doing univariate. You haven't done the regression. There you can do the permutation. You can reshuffle. But if you do the permutation using the model, it will give you the answer, but it's, when you say garbage in, garbage out, it's just garbage. You don't do the permutation. You do this one only for the residual of the linear model. Don't go far. Don't do the permutation. Just do this. That's all. If you find spatial dependence, what you need to do, you can now run what we call Lagrange multiplier test. This is the Lagrange multiplier test, LM test, to choose which one is good and which one is not. So like in this case, I can run this model. In 5 minutes, I will finish. I can run this model, but our model was, remember, it was LM model, because we didn't run the other one, LM model, and our matrix was W list W. So let me run. I've run. There it is. So if I want to see it, the Lagrange is good because it will tell you not only that there is spatial dependence, but it's choosing now which one of the spatial model that we need to run. So you see, the first one is Lagrange multiplier for spatial dependence. It says, the first one, it gives you diagnostic for spatial dependence. No, this is the first one, LM lag. LM lag, it means that we are now testing for the spatial dependence in the dependent variable. So this is the value, and this is the p-value. So we can take that this is good. This one is in R. LM, you can see R, dependence in the error term. It's also good. This one, it's what we call robust, because these tests are not independent. It means that you can say that there is spatial lag, but you are not saying in that spatial lag, do we also have spatial error? That one you don't know. So now you need to go to the, because now it has given us the answer in both. It has said lag and error. So you now need to go to the robust. When you go to the robust, you can see that it gives us both answers, which becomes complicated. How do you choose? That's where the problem is. You can see even the robust is telling us that both models are still good, but which one do you choose? Which one do you choose? It becomes a problem. That's why I don't like this approach. It's because of this reason, because it becomes very complicated to choose. It's better I run the big one and I choose based on IC, that's all, and I interpret my result. So in 2 minutes, let's see the last one, the LRA. You see the LRA is there. So you run first this one, then you compare LRA, all these things. You can do it manually. That's what we've done here. So yeah, I think we are done. It's unfortunate that we didn't finish with everyone, and because of time, we didn't estimate the time properly, but at least it has given us a sense of what we mean by spatial econometrics, how to run. The most important thing is the data. You should know that you need space, you need attributes, and how do you put the data? And you need to test, you need to estimate, and you need to test. So that's all. That was spatial econometrics for cross-section data. So the rest of the information, you have everything. I'm very available. If you need any question, I'm really available. I'm very happy to do it. And we'll see if we can have a second workshop maybe in the next semester, where we will look at panel data, or we can look at geographically weighted regression, and so forth and so on. We can do that. It will depend on what Sachi will tell us, so we'll do. Thank you very much. If there are questions, we can take 1 minute questions, then we are done.
Thank you.
Hello, are we there?
I just wanted to say thank you.
Yeah.
Yeah. Thank you. Yes.
Doc, mine as well is to say thank you, and thank you for inviting and giving us such an informative workshop. I really enjoyed it, and I learned a lot. And please, if we have other workshops, please invite us.
Thank you very much. We'll do that. Thank you very much.
Thank you.
Thank you very much, Olivier.
I suggest
Thank you very
that
much.
Okay, thank you,
remain
thank
in
you, thank
touch.
you, thank you, thank you, Prof.
Thank
It
you.
was a pleasure, and I learned a lot.
Thank you.
Thank you.
Yeah, especially this Studio R and even the macroeconomic, the concept of spatial econometrics. I learned a lot.
Okay.
Thank you very much for that, Prof.
You are welcome, sir. Prof. Gepa, you wanted to say something? Okay,
I'm saying
Jalix,
that
sir.
we should, with Professor, we should see how we can perhaps initiate a process of data collection at the university level, because there are important databases that we are missing in developing countries.
No,
And
thank you very much, Prof.
Yeah, all right,
Yeah.
thanks.
No, you can continue, Prof. I was saying thank you. You can finish what you wanted to say.
Yeah, what I was saying is that please, I would drop you an email for references, those references of the books, the book on R and the book on data for spatial economy.
Okay. Okay.
Yeah.
Okay. Thank you very much. I would also want to thank you for honoring this. At least now I've got an idea of next time when I want to do it, how I can do it in a proper way so that everything is covered. So really, thank you very much. And particularly the spirit that you came in with, which was not a spirit of contestation, but a spirit of trying to assist, which is very nice, because now I know where there are mistakes, I will correct them and put the things in the right. And thank you also to Quotation for organizing. She's the one that is organizing this everything. So mine was just to come and talk. Thank you very much, Quotation. And we'll see, yes, what we can do. Thank you very much from my side. Bye-bye. And yeah, all the best for the rest of the year.
Thank
How
you.
do we get the recordings?
Thank
you. Quotation, can you assist us with the recording? How will we get the recording?
Yes, I'm just waiting for this one to send. And then once it sends to my inbox, I'm going to send both for yesterday and today.
Okay. Thank you very much.
Thank you.
So for me, I'm leaving now. Quotation, I'm leaving. Thank you very much.
Adios. Bye.
Thank
Bye.
you.
Bye, everyone.
Amigo.
No.